the second day with our presentation, RPKI Usability by the team. Team, please introduce yourself.
Good morning all who made it. Thank you. My name is Bruijnzeels. I work as for RPKI as a principal engineer, RPKI. Some of you might know that I used to work for RPKI in the past and then worked at another organization for a while, another labs, but now rejoined RPKI and happily so. I want to talk about the work that we do on RPKI. There's a lot of stuff that I could talk about. For example, I could talk about how we maintain our infrastructure, what we do with hardware security modules, for example, and high availability and all that. But today I want to focus on usability in the broader sense. So what we're doing with the user interface and what might be coming next in terms of things that you can use the RPKI system for. So, next slide. One of the main efforts at this moment is to rework the user interface. And why is that? Well, there's a couple of reasons, technical reasons, maintenance reasons. The UI that we have is quite old, and then as code gets older, then people become afraid to touch it, and it becomes more difficult to make changes, and that's just how the life cycle of code works in a sense. So it's good to keep this fresh, up to date with latest standards, latest libraries that don't have security holes in them and all that. But there's also some usability aspect to this. So we have a UX expert on board. I think we have more than one, but in this case, Antonella did user interviews, and we figured that our current ROA interface is actually, well, it's pretty usable, but there are some things that it doesn't do well, in particular when it comes to making changes and having a number of pending ROA changes that you want to apply, and then there's a button that's like somewhere in the bottom right of the screen that you have to press to know that, okay, I need to do something else to finish my task. And that's something that we're, as an example, I wanted to highlight that we're now making much more explicit. So when you make any change, you can say, well, I want to apply this change now. Or you can essentially say, it says here, 2 pending changes. I think I'll change that text to something like, keep making more changes or something like that, or make more changes, because that's essentially what you would do. In this case, I had to use a test system, and I didn't want to use somebody's real resources. So I just used the right meeting network. Which means that on the bottom where we say affected announcements, you don't see anything at the moment because the right meeting network is not being announced at the moment. But normally you would see what the effect of your ROA is. So in case that you make a ROA for a certain announcement and it would invalidate something, then, well, you could choose to apply this now, but then you would invalidate some announcement. So that may not be what you want to do. You may want to then take the option to go, to the other box and keep making more changes until you're happy with all of them and then apply them. So this is just an example of what we're working on. The plan is, well, we're working on this. My idea is that, well, we can deploy this in the live environment and give people early access if they want. If you are interested in doing in that and having a look, then you can talk to me in the hallway, or my email address is on the last slide. Right, train of thought. So, beta testing is a thing that we want to do. We want to be sure that this is free of bugs and that we have all the features that the current user interface has before we put it live. Most likely that will be somewhere this summer. Now, after that, we'd like to look at other RPKI objects, for example. ASPA in particular, I'll talk a great deal more about that in a moment. BGP-SEC router certificates is something that we could do, probably API first and then user interface later. Resource signed checklist, I'm not sure that anybody heard about those, but there are essentially detached signatures where as a resource holder you can make a signature over an arbitrary file, saying, okay, I, as holder of these resources, you know, sign to the hash of this file, which can be used for, well, any purpose that you come up with, really, in the context of who holds resources. Another thing that we may look at is a faster feedback loop for BGP information. So currently, we use the RIS-who-is dump files that are created every 8 hours. So the information that we show you can be quite old, but maybe, you know, you have other ideas, and again, I would say, please talk to me if you feel that anything is missing or you feel that anything has high priority. With that, I'd like to dive into ASPA a bit, actually, and evangelize it a bit as a coming thing. But first, we need to look at origin validation. Now, many of you probably know this already. So with ROAS, you have the authorization part and you have the validation part. So ROA is root origin authorization. Prefix holders make signed statements about which prefixes can be announced by which ASN. And then network operators can do the validation with relying party software. And it allows you in this example to detect that, you know, in the bottom right of the screen here, there is a misorigination, and it's detectable because it's a prefix that is not allowed for that ASN. So it would be dropped. However, in terms of strong security, path spoofing is actually quite trivial. So if the ASN were malicious, they can just prepend the path with an AS that would be allowed, and then it all looks fine. So in today's world, ROAS do give us value. They protect mainly against typos. They also attack, well, against somewhat naive attempts at hijacks where somebody doesn't do path spoofing. And they protect against hijacks where, you know, a provider knows, okay, these are the ASNs that I can expect here from my customers, and I simply won't allow other ones. So in that case, you have external information that you can use to think about the path. Beyond ROV, there are a couple of initiatives, one of which is ASPA. It's I think it's AS provider attestations or something like that. Yeah, essentially, they're designed around preventing root leaks. But they will also enable detecting certain other mistakes in the path, or malicious or not. It's designed for incremental deployment. It describes what a plausible path would be, like what providers you might expect after a customer ASN. So as a customer ASN, you sign an object saying, these are my providers. Whether that's a provider in monetary terms, that's not what's at stake here. It's whether they are a provider in the terms of BGP. So if you're peers and, you know, it's a bidirectional thing, then you could sign for the other, and, you know, your peer could sign for you. Those are independent and don't influence each other. The cryptography would be handled by, well, the CA system would make the signature, and validators validate this stuff, and then the validated content is made available to routers. Alternatives, well, BGP SAC has been talked about for a long time. Works a bit different, and it's actually orthogonal to this. In BGP SAC, you would publish a key for your router in the RPKI. That statement would be validated by a relying party software, and then your router would learn about which ASN and which key go together, and then sign and verify updates. With BGP SAC, you would be able to say, we know for sure that this is the path on the control plane that this update went through. But that's a different question from, is this the path that it was actually supposed to take, which is what ASPA is trying to solve with essentially leak detection. PLOC is in use today, and well, I think rightfully so. But if you compare, it has some similarities with what you would do in ASPA. but it has no signatures. It's a bit harder to scale, so where do you get all the information from? How do you know that it's actually valid? And the implementation on the router side, basically means that you need to work this into configuration. Whereas once completed, ASPA will allow you to say, make statements in policy like ASPA invalid, drop, which would be easier. Until we get to that stage, ASPA information might actually be used in a similar way to how PLOC is used today. So how does it work? Well, I don't want to go into the formal explanations because they're quite hard to follow, in my opinion, but they do exist. So I left some notes here for people who really want to dive into that. So there's the document in the ITF. There's a formal proof of correctness, which I actually studied biology, so the formal proof of correctness in these algorithms is a bit difficult for me to read, but maybe, for you it's not. I'm happy to accept that it had enough eyes and that it works. There's also another presentation that I linked here that's by Ben Madison, who goes into a lot of detail about this, which may be interesting to watch. But here I'd like to just quickly go through the gist of what this is trying to do by example. So, example. In this case, let's say AS 65552. They're really unpronounceable, these documentation numbers, right? They can verify AS to AS hops in paths that they receive because from customers, because you would expect that either those customers in that whole cone made no statements about who their providers are, or if they did, then that any provider seen would be listed. So in this case, the bottom right one made statements about who the providers are, and it's not the red one, so it would be flagged as this is an invalid path. Now, where things get quite clever is that, well, of course, customer to provider relations are quite known, but how do you do this across transit, right? Because, well, then, how many AS hops adjacencies would you have to define? So I think the real clever bit that they did here is that the algorithm actually detects where the transit, where the tier 1 is. They can make a statement specifically saying, we have no providers. I mean, we are a provider to others, but we have no providers. And the algorithm then uses that information to essentially figure out, well, then we expect a valley-free route. So we expect an up-ramp to this transit and the down-ramp and nothing else. Meaning that on the up-ramp and the down-ramp, you expect that it's all customer to provider relations or no statement, in which case things would be unknown. I'll get to that on the next slide, actually. This case shows a full deployment where, this path is actually valid. It's plausible up and down. In this case, you have incremental deployment. So the outcome of the whole path, in this case, would be unknown, but not invalid, because it could be okay. But, you don't know, essentially. As with ROAS, the advice would be to drop invalid, but not unknown. In this case, a tier 1 actually made a statement saying we have no providers. And now if you see any relationship on one of the ramps where somebody clearly is not the listed provider, then you could flag that as invalid. So also in future deployment, if transit tier 1 networks make these statements, that will go a long way into protecting against a lot of leaks. For example, this one. In this case, there was a leak by AS 6552, like in the middle, and it would be clearly seen as an invalid ASPA path. And this is what they sometimes call like the valley-free routing. So here you have the valley between two transits. That's the basic idea. Is it ready? Well, it's close to IETF last call, but it's not called. Specifically, there's some discussion about whether customers would need the ability to say, these are my providers only in a IPv4 or IPv6 context, or that we don't need that. But once the discussion on that is settled, we would very much like to support this in our user interface as well. It's already supported in other applications. It's already supported in the test environment of RPKI. There's validators that employed it, and certain routers, well, root server software, OpenBGPD implements it, and Calgary Internet Exchange is actually using this information in their network today. So I say it's pretty close to done, but not completely done. But don't be surprised if you see this happening sometime this year. Hopefully, we'll get closure in the IETF soon. And that brings me to the end, actually, of what I wanted to highlight today. But to reiterate, yeah, so I wanted to evangelize ASPA a bit, because I think it needs, it's ready for more attention than it has been getting. We did a lot of work on the UI. It's still ongoing. If you're interested in looking at it or participating in beta testing, once we get to the stage that we can deploy this alongside our production UI, then let me know. And if you have any other questions, well, I'm here. And not always.
If there are any questions, please go to the mic.
Good morning. Thanks, Tim, for the nice talk. I'm Isabel from Max Planck Institute, PhD candidate there. I have a question about the correctness of the records created either for ASPA or ROVA. Mm-hmm. Before publishing, do we have any mechanism to ensure that the ASPA object or a ROVA that's created, mm-hmm. let's say at the right portal, is correct? Because, or could it be that also that an invalid information is injected as an ASPA, as an error or as a whatever, and how to prevent it? Like,
yeah, let me go to there, all the way back. So for ROAS, we have a system. And down here it says affected announcements, and unfortunately I didn't want to use a real, a real alias network for this slide, because I don't want to put your resources on here. But normally we have information for ROAS, we have information from RIS about which announcements are seen. That is shown as a suggestion, because likely that is what you want to authorize, but you're in charge. It may be that there's actually hijacks going on that you don't want to authorize. Maybe that things are not seen that you want to authorize. So in the end, the user decides. But if we see that something would become invalid based on the information that we have, you get a big warning about this. And actually, it will stop you from publishing unless you explicitly type in the word invalid in capitals to really say, no, I know what I'm doing, I want to do it. So that's how we deal with that with ROAS. With ASPA, I still need to talk to the other teams at RPKI. But we are thinking about, getting that information about BGP paths and showing to users, well, these are what we think your providers might be. But in the end, again, it's down to the network operator to really decide on that. Like, we may be wrong, and it's your network, you should know.
Okay.
Alain, Durand, ICANN. When I hear your presentation about ASPA, I'm starting to get nervous. And the reason is there are two time constants that are playing out here. One is the propagation time of all this information within the RPKI system, mm-hmm. with the updates and all of that. And the other is what is happening in the real world when ISPs may be reconfiguring network in real time because they're responding to an attack or responding to some kind of an emergency situation. Mm-hmm. And I'm starting to think about how those two things will somehow interact. Is one going to prevent the other from actually working?
Yeah, so ASPA and root ROV are combined, they're orthogonal to each other, but I don't think that's what you're asking, but the problem that you're talking about exists also for ROAs.
That's correct, yes.
So,
but I'm afraid that this is going to be amplified here.
Right. Well, yes, you would need to pre-provision, list your providers that you're going to use. There have been studies into how long it takes between making a change in the RPKI system and it ending up in routers, and it's somewhere between 30 minutes to just over an hour. So that can be quite long if you need to do a change right at that moment. So there are some eyes on this at the IETF about how we might want to improve this, but I think there's work to be done. In the real world, you would have to pre-provision. You would have to think ahead, like, okay, if they're potentially going to be my provider, but not today, you would include them.
That's my point. If you pre-provision, that's very different from reacting to an emergency.
In that case, it would take time before that statement is known. Yeah, and that time may change in future, but today that's around half an hour, like median.
And we have one more question.
Hi, Tim. It's Vesna. I'm speaking as a RIPE community member. What is the forum where the operators can discuss this and give feedback and feature requests to the RIPE NCC? Do you recommend only IETF, or is there within a RIPE where we can talk about this?
Well, I would love it if more operators would participate in the insider ops at the IETF, because I think, yeah, the IETF can use more operator input. But I'm active there, so I'm also happy to relay anything that people want to bring to my attention. The routing working group is also a good place to discuss this. I guess your usual channels.
Do we have another question, maybe? If not, thank you. Now we have another presentation from Maria Isabel Gandia Carriedo, SIG-NOC tools survey results.
Okay, thank you. Good morning, everybody. Thank you for being here after a wonderful dinner and social yesterday. I know it's not easy to wake up. And, well, as he said, Maria Isabel Gandia from a consortium of universities in Catalonia. So I'm not from the South European Eastern country, I'm from the Southwest one. Thank you for having me here. Maybe some of you know me because we also manage the Internet Exchange in Catalonia, Canix, but today I'm talking on behalf of GEAN, of the GEAN project. I'm showing you some results of a survey we did on tools used by network operation centers in 2023. Before we start, this presentation is about these results. I have no interest in promoting any of the tools or in going against any of the tools shown here. It's not in my opinion, it's a survey result. To introduce the GEAN project, for those who don't know it, we had a wonderful roundtable yesterday about EARN. It was the seed of the GEAN network today. EARN was the first research and education network in Europe. GEAN is the research and education network that it's uniting, it's linking all the national research and education networks in Europe, but it's also other things. We use the same name for several things. We use the name for the project that has more than 50 million users. These users that use the GEAN network. It's also the Association of National Research and Education Networks, this organization, GEAN, that manages the network. And it's, well, the project, the community, the network. The GEAN project has more than 500 people working on it. I'm one of these 500. And there have been 9 projects of the GEAN, or 9 phases of the GEAN project so far. You can see all the different topics that are treated in the GEAN 5.1 project, from trust and identity to security to network development to operations. And maybe you remember from last year, from RIPE SE 11, Eldis Mujaric from Carnet did a presentation on the Network Key Academy. This is one of the topics we deal with, and this is where I work mostly. And also, we have, under this GEAN umbrella, special interest groups. These special interest groups are people who are together to exchange information about topics, about different topics, about best practices on different things, about ideas, information in general. We have 6 on organization and support, on education, on clouds, and also on networks. And here we have, for the network, 2 special interest groups, NGN, Next Generation Networks, and Network Operation Centers. So for network operation centers, what do we do? Well, we're a community. We have a mailing list, of course, where we exchange information from time to time, or someone asks about something, and then we just exchange some emails, but mostly it's about being together. So we have 2 meetings per year where we talk about taxonomy, services, tools, networks. It's pretty much like a NOC, like a SNOC or your NOC, but for research and education, for the research and education community. There we exchange knowledge, and you see that I have highlighted with red squares some of the things that have to do with this presentation. We develop the survey. We meet, we think about the questions that we are going to include in the survey, then we fulfill the survey, then we ask about tools and standards, and after that, we have the results of these surveys. We have run 4 surveys so far since we started in 2011. The first survey asked about anything you can imagine on NOCs, so about taxonomy, also tools, structures, resources, standards, you name it. And there were 14 functions, you will see them later. But we wanted to be very open about the survey, so we had many open boxes. And then after we answered the survey, we realized that it was much easier for the respondents to have options to click instead of having to write the options or having to write all the tools. And on the other hand, to analyze the results, it was much easier to analyze the results if you had a list of tools than just having to go through the open boxes and finding where the tools had the same name, etc. So for the second survey in 2015, we only focused on tools and standards. We added 1 function. Interestingly, in 2011, NOCs didn't think about DDoS attacks because there were not so many. Maybe we didn't have that problem in the research and education networks yet. But in 2015, we certainly thought that we had to add DDoS mitigation to the list of tools, of functions. We had 35 questions, 64 valid answers, and we had a rating on importance and quality. So importance had 4 different degrees, from low to high. Quality 5 degrees, from poor to excellent. That's very subjective, but we wanted to know. The third survey was quite the same, but with orchestration, automation, and virtualization as the new function. And the fourth survey, the one that we published by the end of 2023, had 17 functions because we added training, because we knew or realized that NOCs, when a new NOC engineer comes to an institution, to an entity, they are trained by the NOC. There is not a training department that just takes care of them. It's the NOC who trains them. And we got 82 responses, but we always need to clean them up a little bit, and so we ended up with 68 valid responses. Why? Because we want to know who has answered the survey. Then we can anonymize the results when we publish them, and you don't need to be there in the list, but at least we need to know who you are or where you come from, because we only want one answer per institution. So we don't want 10 people from one institution answering and having the same response 10 times. We want to know which tools this institution uses, and they know that. So if we have more than one response from an institution, we talk to them, and then we decide which one to use. If there is just not a valid name, if they just put XXX as their name, then this is not valid either. If there is only one, yes, I use this, or I am responsible for this function, but they don't answer to any of the tools or they don't rate any of the tools, then it's not valid either, and if it's duplicated too. Only we included one institution that contacted us and told us that they have answered twice, but because they have 2 different departments taking care of the different functions and using different tools, and that's why we accepted that. The structure is the same for the survey and for the results, for the report we publish. You have the short definition of this function. We ask if your NOC feels responsible or is responsible for this function. If it's yes, then we ask about the tools. If it's no, then we jump to the next function. And the predefined responses are those that were rated more than twice or more in the last survey, with some open boxes for in-house tools and other tools. This is how the responses look like. With the graphs we have for each one of the functions are like this. So we try to have 3 dimensions in a 2-dimensional graph. This means that we have bubbles. The bigger the bubble, the more institutions use that tool. The small bubbles means that not so many institutions use that tool. And then you have the importance on the x-axis and the rating on y. So here you have a very popular tool because the bubble is very big, very important because it's to the right, and very good rating because it's up. On the contrary, if you have this tool here, this is very important for a few number of NOCs, but low rated. Not really, they don't feel it's really very, very good. This one is medium people, medium NOCs, a medium rating, medium importance. And this is a tool that could be used by many NOCs, not very important, but very good rating. That's more or less the idea of these graphs. We also publish, as well as the report with all the graphs, a matrix. The matrix is also 3-dimensional somehow. We have the functions there. We have all the tools, more than 150 tools here. And then for each one of the tools, the number of users that use it, for how many functionalities each tool is used. And then if you download the Excel file and you go to the cell, you get the list, as a comment, the list of institutions that wanted to be included. Of course, if they are anonymized, they are not there. But you have the list. And there is a reason to have this list. This is a small community. We know each other. If you know about a tool, you're using a tool, and you want to know something about this tool, and you know someone who is using it already, you can poke them directly because they are at the community. The type of network that our NOCs manage is especially national research and education networks, and also campus university networks. There are more than 68 because some NOCs manage more than one network. Especially NRENs usually also manage internet exchanges. Some of them manage campus university networks too, or special research and education project networks. And these are the functions. This is the list of functions. For all the tables we have in the report, there are 3 columns with the last responses from 2016, 2019, and 2023. This is the position in the ranking. So here is 1, 2, 3, 4, 5 always, but then the position they had in the previous surveys. And this is the trend, if it's in the same position, if it's up, or if it's down. Monitoring. NOCs are always responsible for monitoring. Then problem management, and then ticketing. They are always the 3 most relevant functions. Interestingly, this time, knowledge is going up. It looks like the NOCs are more aware of the importance of documentation. This is not something we like, but it's something we need, and then we know about the importance. And on the other hand, security has dropped 6 positions since the last time, and this is probably because some institutions have started working with SOCs. There are many SOCs right now, security operation centers. They take over this function from the NOC, and the NOC is not responsible for security anymore. The average number of tools per function, if the results of the survey show us something, is that there is no one single tool that works for everything, but also that there is no one single tool that works for a single function. I mean, for monitoring, there are more than 11 tools used on average per institution. This means that if you are an average NOC, you are going to use 11 tools. SNMP tools, flow monitoring tools, syslog analyze tools, RIPE Atlas, for instance. So ICMP, there are like many views of the network you have from inside, from outside, with different ways of looking at it. On the other side, you have ticketing. You usually only use one tool for ticketing, maybe two if you're using it for different functions. You're using different tools, maybe one for security if you deal with it, or another one for network incidents, or maybe one from an external provider. But the function that uses more tools is clearly monitoring. The one that uses less tools is ticketing. And the first thing we asked for was not about specific tools, but about which methodology you use for monitoring. We asked, are you using streaming telemetry, which is quite cool? Or are you using the old-fashioned SNMP? Well, it looks like SNMP is very popular, still very popular. We use SNMP, it does the work, it is good for monitoring, it's going to show us how the network is going. After that, NOC responded that flow management tools are the second in popularity, let's say, but a little bit rated than syslog handling tools. Maybe this is just not my opinion, but from the survey, this is what what you have. And streaming telemetry is a little bit bigger than last time, a little bit more important, a little bit more rated, but still, it has room for improvement. It has room to go up and to the right. It's not yet very popular as a methodology to monitor the network. In regards to monitoring tools, there are so many. I animated this graph to make them appear slowly so you can see them. They appear in alphabetical order. It's not in order of popularity, but you already see here that Grafana was the most popular tool this time, followed by Nagios. And you can see here, for instance, other tools like Personar went very up in the ranking. Rancid, RIPE Atlas is used by many institutions. RIPE-RIS is also used by many institutions, Splunk, Suricata. So you have all kinds of tools in regards to monitoring. This graph is available. You can download the Excel file with the numbers and the graph if you want to just take a closer look. If you want to zoom in, this is the zoom for 5, the top 5. So the top 5 is Grafana, Nagios, the old MRTG, still very popular among the NOCs in the research and education community. Personar, RIPE Atlas, and RIPE Stats. Well, all these RIPE tools, wonderful tools. If we go to the top 10, we add other tools like the ELK stack, weather maps, looking glasses, NFSEN. And if we go to the top 16, you see this. And why top 16 and not top 15? Because RIPE-RIS was on the 16th position, and I wanted to show this RIPE-RIS here because this is the RIPE NCC meeting, and also because you will see that for problem management, RIPE-RIS goes up in the list. It's not in the 16th position. This is Grafana is used by more than 70% of the NOCs who answer the survey, so it's a really popular tool in the research and education community, followed by Nagios, also more than 50% of the institutions use it, and then MRTG and RIPE Atlas are used by 50% of the institutions who answer the survey. Interestingly, Grafana was not appearing in the previous survey, but it was mentioned more than twice, and we added it to the survey, and it went directly to the first position. Nagios and Cacti are still popular. They were more popular before, but now are still popular, still at the top 10, and MRTG is going up. Personar, that was not in the previous top 10, is now going up 7 positions for the first time, and SmokePing and NFDAM disappear from this top 10. Then for problem management, you can see that all the balls or these bubbles are quite close in the middle of the table. You can go from 1 to 4 here, nothing at 4, or from 1 to 5 in the y-axis. But everything is quite close here around the middle of the table and quite up. So the rating for problem management is quite good. The importance is medium. And here you can see Nagios, it's important, request tracker, and also, as I mentioned before, RIPE-RIS makes it to the top 10. This time it's in the 7th position, maybe because we don't use it for monitoring daily things, but we use it when we have problems, and then it's useful. The mix you see here, there is a real mix of open source, vendor-based, and distributed tools. There is a little bit of this, a little bit of that. Nagios, RIPE-Atlas, Confluence, so we have one of each in the 3 first positions. Jira goes down a little bit from the 1st to the 3rd position. Jira was in the 1st position in 2019. It was very popular after being in the 11th place in 2016. But then it went down again, and we have seen this trend also in other functions because, you know, they changed a little bit the way they were offering their services, and maybe that was the reason why they went a little bit down. People are starting to move from Jira to RT or to other tools because of this change. For ticketing, there are not so many tools. Jira and Request Tracker. Request Tracker is going bigger, having a bigger bubble this time. Good rating for both of them. Good importance for both of them, a little bit less for OTRS. And then we have ServiceNow and Zendesk, not so used, not so important, not so well rated. Anyway, for ticketing, there is no single tool that is used by more than 50% of the respondents. It's quite scattered. All the responses are quite scattered in this case. Request Tracker goes back to the 1st position after leaving it in 2019. But, as I said, not even the most popular tool reaches 50% of this in this question. And there were other tools mentioned here. For documentation, well, we have many tools for documentation tools. We have Confluence, we have GitLab, and we have others. If you look at the number of users who use each one of these tools, Confluence and GitLab are used by 50% of the institutions. Then you have Netbox, Microsoft OneDrive, etc. New tools appear in the upper part, new tools that we added in this survey, like GitLab, Netbox, or Nextcloud. And several of them that were in the 2016 survey are going down, like Google Drive, Wiki, and OnCloud. They were 4 positions down. Then OTRS, SharePoint, MediaWiki, Request Tracker, they disappear from the top 10. And for reporting and statistics, Grafana strikes again. Then we have Request Tracker again, and all the other tools you can see here. You can analyze it on your own, you can see that. But again, Grafana and Request Tracker are used by more than 50%. And Grafana is, again, the most popular tool. For communication, coordination, and chat, yes, we use emails. Yes, we use mailing lists. Wow, surprise. But we also use, thank you, we also use other tools like, you know, communication. Then you have many channels at home, like Slack, Mattermost, WhatsApp, Twitter, whatever. So we have so many communication tools, and this is for bidirectional communication, that it's like a little bit crazy. You need to deal with many of them at the same time. If you look at the popularity, yes, we use email and mailing lists, but for bidirectional communications, only 60% of the NOCs mention them. This means that 40% of the NOCs just moved from mailing lists, just moved away from using emails, and they are using different chat tools like Teams, or they are video conferencing via Zoom. Interestingly, we don't use the phone anymore. Telephone calls, who picks up the phone? They disappear from the top 10. They were there before. Now people don't want to call unless it is just impossible and you need to call via a landline. We don't make telephone calls via landlines. And we have also Edumeet is at the 12th position. For unidirectional communications, and we separate that because this was a decision of the SIG-NOC community, we also have email and mailing lists. We don't have so many tools as for bidirectional communications. And in this case, yes, email and mailing lists are more than 90%. So if we want to communicate something, we use mailing lists. If we want to talk to the institutions, then we don't use mailing lists so much. We use other tools. IRC had 0 users this time. And some organizations are using Twitter for unidirectional communications. It's like shooting in the foot sometimes, but yes, they use Twitter. For configuration management and backup, Git is the most popular tool, then Rancid. And you see here, we have like a line that all the tools that were voted have. Subversion went a little bit down, and IMS and CVS have the same number of answers and ratings. Git and Rancid are used by 70%, around 70% of the institutions, which is a lot. The rest of tools are used by less than 50% of the respondents. Other functions, we have so many that I could not include all of them here. You can take a look in the wiki. All these functions that you see in this slide are not in this presentation, but they are in the report. Fun facts about them. We have inventory management for devices and the inventory, classic inventory, and resource management for IP addresses, VLANs, this. So we're still using Excel files. We have many, many tools. We have Confluence, and we have Netbox, and they are really best rated, but Excel remains the most popular tool, so we're still using Excel files. Again, the SOCs are probably taking over this function from the NOC. Less than 50% of the NOCs who answered this question didn't feel responsible for security anymore. And automation is still the function that less NOCs feel responsible for. You have all the answers in this link here. I invite you to take a look. And some conclusions. Well, the ecosystem is huge. There are more than 150 tools used by NOCs, not all of them used by all the NOCs. The other is that there is no tool that has all we need, even for the same function. There is no tool that works for all the functions or even for the high percentage of them. And there is a mix of open source, vendor-based, and distributed tools everywhere. If you're starting a NOC, if you have not started with your NOC yet, this survey can give you some ideas. It's from the research and education community, but it can be extrapolated somehow to anyone. So if you take the 5 to 10 most popular and best rated tools, you should probably be fine. The survey is going to help you understand which tools are more popular for the community, at least for the research and education community, and for which functions, and also past trends. And you can just see how it went. But if you have a wonderful tool that works for you, and even if it's not here, you don't need to change it. Of course, this is just to have some results. And with that, thank you very much. Any questions?
Do we have any questions?
No?
Okay,
You do.
we have
Okay.
one question from Vesna.
Hi,
Hi.
thank you for, this was so useful. I'm sorry you only had 30 minutes because I'm sure you could have told us more. As a community builder, I have a question. Your SIG-NOC meetings, are they open to other participants or only for the
They are open. They are open. And we try to have one presentation from a commercial company for each one of the meetings. So we try to have most of the presentations from the research and education community, but we always invite one commercial provider. And the mailing list on the meetings are open to anyone who wants to join, of course.
Oh, thank you. And is there a calendar where we can see the dates and the places?
Yes, there is a wiki where if you go to the survey link, you will see on the left side all the meetings, and you can see the previous ones and the next ones. So, yes.
Thank you.
Thank you. Any other questions? No.
Do we have another question? Maybe. If not,
Okay.
thank you.
Thank you.
Our next presentation is from Alain Durand. Could Anycast help mitigate RPKI incidents?
Good morning. My name is Alain Durand. I work at ICANN in the office of the CTO, and we do all kinds of research and presentations and papers on different things related to the internet and related to the DNS more specifically. So, yes. Today I'm going to talk about RPKI incident that happened early January to Orange Spain. So I know Orange Spain is not part of the SEE, is part of West Side, like you were. But I think there's still some very interesting lessons that we can take from this. This presentation is not about finger pointing. This is not about to say something bad happened or they did a bad job or whatever it is. But this is really trying to look at this and see what can we learn from it. We did reach out to Orange. We had some conversation. We couldn't get feedback from the actual engineers working at Orange Spain. We are still trying to get in contact with them. So this is not something that's done in their bag. So first off, I would like to ask, how many of you are aware of what happened during this incident? Yeah, fair number. Okay, good. So for those who are not, essentially what happened is there was some kind of an hijack of an admin account, and the hijacker used that admin account to go into the RIPE database and put some invalid stuff in there, essentially taking out the entire network from the internet. And then it took a number of hours to repair all this. So a problem like this should not come as a surprise. It has nothing to do with a weak password or something like this. It has to do with, we introduce a new system to improve security, but because we introduce something new, well, there might be some issues with how things are done. So we need to learn from this to make sure that from an operational perspective, in the future, things will get a little smoother. We are from ICANN, we are not the network police, right? But we do operate a service from a DNS root server. So ICANN has one of the 13 root servers. And we went to the, all the logs and all the data that we have. And we try to see, was the service from ICANN impacted for the people from Orange Spain or not? So was our service still available to them during this outage? And if it was not, what did happen there? So IMRS, like all, I think now all the root servers, is using Anycast, which means there are a lot of different instances in the world, and you can go to any of them. So the first thought that came to me was, well, if there's Anycast, maybe that could help us in case of a network problem, because instead of going to where you thought you were normally going, maybe you will go somewhere else if there's a route that enables you to go there. So is it kind of a fail-safe or not? That was how I started this. So a little bit about IMRS. It was known as LRoot a few years ago, for those of you who may remember. There's 191 instances all around the world. So we have a bunch of them that are grouped into clusters, like in Los Angeles, or in Europe, there are a huge cluster in Prague, and there are different clusters that are being bought everywhere. But there are also like smaller instances that could be with providers, or could be next to exchange points, or different places. The idea here is that having a lot of instances all around the world will help us to essentially reduce latency when you try to go to a root server. And also to have some kind of localized traffic. So if you have an instance, let's say, in Spain, you expect that the Spanish traffic will go there. If you have an instance in Greece, you expect that the Greek traffic will go there. That's kind of the ongoing assumption there. So this is located in 84 countries, so it's really in a lot of places. So what we did is we got data from January 1st to January 8th. So incident happened on January 3rd, a couple of days before, a couple of days after. What we have is essentially TCP dump files. So we have all the network traffic being captured, going to those instances. So we have one file per instance, each file capturing a 5-minute time lapse of traffic. This is all compressed in a format known as CBOR, that's very efficient to compress, not so efficient to read First thing was to collect all of this, align all the timestamps, and then try to extract all the IP addresses that were hitting this IMRS service and to isolate the one that are coming from Orange Spain. So essentially we look at the AS number from Orange Spain, try to find all the prefixes that were associated with that, and if the addresses were within those prefixes, when we said, okay, that's an IP address from Orange Spain hitting the root. So we look at all the instances and see how many addresses from Orange Spain were hitting those particular instances, and we try to see if something changed during the week, okay? So I'm going to ask you a question. How many IP addresses from Orange Spain should we see? 1, 2, 10, 100, 1,000? So who think it should be less than 10? No, one person. Who think it should be less than 100? Nobody? Less than 1,000? Couple of people. More than 1,000? More people. You're correct. Well, that was still our expectations. Like, do we see queries moving to an instance or the other? So let's try to show you some data, some real data. So here's the answer to my question. How many? Well, total we saw 10,000 addresses. 10,256 IP addresses. It's quite a lot. Because if you think about it, it should all come from resolvers. That means that there are actually 10,000 resolvers in this AS number that are operating. It's a bit of a scratch here. Why so many? So, if you forget the colors for an instant, what we see here is a pattern for the week. So you see peaks and valleys. So that's kind of expected. Things happening at night, or things happening during the day. So less activity at night, more during the day. That's normal. There's no discontinuity there, which I could stop my presentation here and said, okay, nothing happened. But that's actually not true. First, there are some weird things. Now I started to look at the colors. So you see some gray, some orange, some blue. It's hard to see, but yeah. We see some traffic going to Brazil. So much for traffic being local because of Anycast, right? What happened then? I don't know. So now I'm going to zoom in during the about 8 hours of this incident. So we actually do see a drop. We don't see a drop to 0, but we do see a significant drop in terms of queries. So in these graphs, you will see the y-axis is the number of thousands of queries per 5-minute slot combined across all the instances. Okay? So the maximum peaked at about, 16,000 queries per 5-minute slot. Most of the queries actually go to 3 instances out of 191. So 1 in Spain, 1 in France, and 1 in Switzerland. Now, I said 10,000 and something IP addresses, but we do some other studies combined with APNIC and a system from Jeff Houston, where we see Google Ads. We send millions of Google Ads per day everywhere. And we have an idea of what are the real resolvers behind users. Not just a random resolver doing some stuff, but things that are used by actual users. And in Orange Spain, we see 4 of them. So those 4 resolvers, if I plot them here, you will see that, yeah, that's the same curve. It's just shifted down by about 1,000. So that means that there's a background noise about 1,000 queries per 5-minute slot generated by 10,000 252 resolvers that are more or less meaningless. And the rest, by those 4 resolvers, is showing this pattern. So for us, that was already quite an interesting finding, is we need to really focus on those 4, not the other 10,252. So if I zoom in, you see that's exactly the same thing. So now what I'm going to do is to go in details about each of those 4. By 4, I mean 4 IP addresses. I'm aware that it could be different servers using the same IP addresses, right? By one address, it could be actually hundreds of, or farm of servers, all behind some kind of a reverse NAT that hide their real identity and on the outside show a single IP address. So here's the first one. The first one is actually covering, well, issuing queries from this prefix, 85.62.233/24. That's one of the prefixes that got hijacked. First off, we see this orange bar here that is happening the day before. Nothing to do with the incident, but something happened. It's just to show when we are looking at traffic, always need to keep in mind that stuff happened. That may or may not be related to what you are trying to look at. Second, then, we do see that there was an impact. That particular resolver stopped being seen from IMRS during this entire period of time. That one was sending traffic to France, and when it came back, it was also sending traffic to France, knowing that there is an instance in Spain. The second one is in an adjacent IPv4 prefix. So the previous one was 85.62.233. This one is 62.229, almost the same. Different colors. This one, before the incident, was sending its traffic to Spain. After the incident, it sent traffic to Switzerland and stayed there for a long while. If I zoom in, you will see that more or less ending at the same time, plus or minus 5 minutes. So I suppose this is RPKI propagation that is impacting some prefixes faster than others. But more interestingly to me, the recovery time is happening much later. If the slides are available, so you could actually zoom in. It's happening there. It's happening there at 19:15. All those times are in UTC, by the way. Well, this one was actually recovering a lot earlier, a couple hours earlier. Why? No clue. But this shift from a server in Spain to a server in Switzerland is really puzzling us. We just don't understand. It makes no sense to us. And I don't think this is a configuration mistake. Or I don't think this is somebody who did something wrong. This is something that we need to understand because it completely defies our naive, I will say, understanding of BGP Anycast. The entire thing is designed to not have things like that. It should go to local stuff. Look at the geography. Spain, France, Switzerland. Should stay in Spain. If it doesn't stay in Spain, maybe France, because that's a neighboring country. Switzerland is not a neighboring country from Spain. Why sending traffic there? Might as well sending to Brazil, as I said earlier. So, now the third resolver. So, going back to those 2 resolvers, they are what we call twin resolvers, because they see exactly the same number of users and queries when we have this system from Jeff Houston and EPNIC. So there actually are 2 identical resolvers doing exactly the same thing in pair, but with different behavior. Now, the third one is in a different prefix altogether. It starts with 86, not 85. That one was not impacted in the RPKI incident. What we see here, if I zoom in, is this one did not drop traffic. Actually, it increased traffic, right? But what is even more surprising to me is that it was not simply an automatic shift from the other resolvers to that one when the incident kicked in. It only started to generate more traffic later on. Look at the onset. This is 16:30, when the problem started around 2 p.m., which means it started 4 hours after the incident took the network away, which suggests, and I don't have proof of that, but it suggests that somebody turned some buttons to actually send traffic there, which may be a good thing. They're trying to improve the service, trying whatever they could. But also very surprisingly, toward the end of the incident, we see this shift from sending the traffic to Spain to sending the traffic to Switzerland. Well, there was no impact on this resolver. It was still working fine. There was no problem at all. But something happened in the network, independent from the operation of the resolver, apparently, that now sent the traffic to a different country. So this is completely counterintuitive. Something that worked should keep working. But because of some fix somewhere else, the behavior actually is different. It's not a bad behavior, it's just different. Completely defies our expectations. So that's the fourth one. So back there. So that one was initially 12% of the traffic in normal days. As you see the spike, it went to maybe about 50%. That's the fourth one, but typically sees 25% of the traffic. Oops. I think the zoom-in slide is missing probably. But on this one, we see essentially zero impact whatsoever. In terms of traffic volume, I mean. It didn't pick up any user, didn't drop any user. But also we see on this one, this shift from sending the traffic to Spain originally to sending the traffic to Switzerland. This one is in 87 network, also a network that was not impacted by the RPKI incident. So what's the conclusion from all of this? Well, at least that's my personal temporary conclusion, and I would like to get some feedback from you. First off, if I simply look from a high-level perspective, IMRS kept serving Orange Spain during the entire incident. So I could say, nothing to see here, we did good. But it's full of surprises. This whole shift from Spain to Switzerland is extraordinarily puzzling. I think it's a supposition at this moment, is backed by some preliminary data, that it has to do with the fact that now networks are all interconnected and the actual length of the BGP path is getting shorter and shorter. So when you get closer to, let's say, 4-hop or 5-hop, there are actually quite a lot of networks that are 5 hops away. And which means that you may be in a tie situation where the BGP path is actually the same length to go to Spain, to France, to Switzerland, to Brazil, or to wherever it is. What happened then? Well, what happened is more or less up to the implementers of BGP routing vendors. Like if you have a Cisco or Juniper or something else, you have different results. So I talked to some vendors, and there are some tiebreaker rules. Things like, okay, if we had been connected to that one, we're going to stay connected to that one in the near future. That's great, improve stability of the network. Other rules like We are going to look at the ASN, and we will pick up the lower ASN number, or we're going to look at the IP addresses, and we're going to pick up the lowest IP address, or there's a router ID, and we're going to essentially pick the lowest one, which I translate as random. So when you have equal paths, this is random, which is a bit maybe not what you would expect when you're designing networks. So how could this be improved? Well, it's obvious that the instance in Spain that we have from IMRS is not directly connected to the network from Orange Spain. It's obvious that there is no exchange point that is connecting the two either. So if there were better local connectivity, maybe this problem will not happen. Maybe if we had an instance directly with Orange Spain, maybe that would be better. But now we're talking about placement. But it's not just the placement of our servers, authoritative servers. We have a lot of best practice rules. We always say if you have DNS authoritative servers, never put them in the same subnet, because if your subnet is cut off, then you will lose all of them, right? Well, it seems that this rule does not only apply to authoritative servers, but also applies to recursive servers. Because if your recursive is on a network that is taken down by something, could be a backhoe digging a hole and cutting a fiber, or it could be an RPKI incident, it could be a hacker, it could be anything like this, then you could lose connectivity for those critical resolvers. So placing those resolvers on subnets that are different might be a good recommendation. So that's the end of my presentation. I wanted to leave a few minutes for questions. This to me, I got my head scratching, so I would like to get your feedback.
And if you have any questions, please go to the microphone.
In the back?
Who will go first? Kish, please.
Hello? Yeah, that works. First of all, thank you for the presentation. Very interesting. My name is Hisham Ibrahim, RIPE NCC. Again, thank you for the presentation. Very interesting. I actually just texted to our researchers to look into K-root and see what we saw during that time as well. I think that would be interesting to see. An observation, not necessarily on the work or the research itself, but about BGP and Anycast behavior in general, because we have done work before, and as you say, when everything is equal, you would expect that you would go to like a shortest path, or it would begin to select randomly. But we have seen traffic shaping ended up playing a role here. So to give an example, a more concrete example, a country in the Middle East that has a K route in a neighboring country, you would expect it would go there because of, the distance, but really because of the way the telcos build their networks. They have like submarine cables all the way to Sydney, Australia, so they prefer to query Sydney, Australia nodes rather than the neighboring country. And it has to do with, like I said, how they do traffic shaping. So we've seen stuff like this because BGP indeed looks at hops, not necessarily distance as we measure it. So there's other factors that play in here. But thank you for this. This was really great.
Thank you.
Thank you for the nice insights. I'm Zubair. I was wondering, because when I look at the report about the incident, it said maybe it was just the news that the ACE was changed for that during that particular incident. And could it be that because the change in the ACE actually affects the traffic, because now the new location in the Anycast thinks that, okay, though it comes from a range or from the incident area, but because it has a new ACE number, so it's redirected to Brazil or other location, because the new ACE is actually closer from that other Anycast server. I mean, it could be or not, but I was wondering if...
So if you have a new AS, but you announce things exactly the same way, the length of the path is going to be identical, right? So it should not change anything from BGP Anycast perspective, unless you arrive in a situation where you have a tie. And if your routers or your ISP routers are using a tiebreaker that's based on the AS number, then it may change. So back to my point, when you have a tie, things are essentially random. You don't know what's going to happen.
Tim Bruijnzeels from NCC. First of all, yes, thank you for the talk, and I find it very interesting to see how the BGP Anycast behavior, what it was, and yeah, what you saw. But I guess it's my turn to get a bit nervous when you keep saying RPKI incident, because I think this was an account security incident, and RPKI just did its job. As another data point, and I should have said this in my presentation and didn't, so I'll use this opportunity. Since the incident, we've actually made two-factor authentication mandatory on the Aliyah portal. So we hope that this will go a long way in protecting access to accounts in the future.
I'm really glad that you're moving to two-factor. This is certainly going to raise the bar. However, two-factor could also be broken, right? So now that's an interesting conversation. Is this could we label this an RPKI incident or an hijack of a password or something? The perspective I have to this is, as I mentioned at the beginning of my talk, RPKI is a new tool that we put in the system to improve the security. Because it brings something new, it brings also some risk. And it's actually very good to make a risk analysis and to understand what are the potential vulnerabilities so we can actually address them before it becomes a real problem. So this is not about to say, oh, it's a dirty baby, let's throw it away with a bath water. That's not the point. The point is to say, well, new things, new attack vectors, new potential issues. Let's look at them with open eyes and see, okay, maybe there's some work that is needed there, and what you did with two-factor is a part of the work. Maybe something else could also be done. Maybe it's something that needs to be looked at from the validator perspective. Could it be that when there's a drastic change, that should trigger an alarm that asks somebody to actually verify if this is really the intended behavior or not? I'm a bit nervous about this idea that something automatically will happen to take out a network. But that's a different conversation.
Well, yes, and suppose it was a mistake, that there was no account breach, somebody logged in and made a change in RPKI, that was wrong, then you might have seen similar behavior, but probably, likely, the recovery would have been faster because they would have known that they made a change and they could have corrected it, and then you would have seen something more in the order of the normal propagation time of RPKI rather than, figuring out where the problem came from and then, solving it, which leads to a longer.
Hopefully, unless by doing this mistake, this typo, finger fat, they actually took themselves down and will not be able to reach the RIPE NCC. So
yes, in that case, you would hope that they have, I don't know,
a landline,
maybe
so they can make a phone call.
A mobile phone of another company that.
Yeah. All I'm saying is no tool is a panacea, and it all comes with downside, and we're starting to see some of them, and learning from that will help us to build a more robust system in the end. But thank you.
So this is all for our first session block, but we have finished 10 minutes earlier, and I hope there is a coffee waiting us.
Hi everybody, so good morning for those who just joined us and got up. First of all, for the next session, I would like to invite Danilo and Giordano from Politecnico di Torino, one of the race attendees here at RIPE SC12. He'll be talking about satellites and watching the internet. Please.
Okay, so thank you very much for the introduction. First of all, I would like to introduce myself. My name is Danilo Giordano. I'm an assistant professor at Politecnico di Torino, a technical university located in the northwest part of Italy. So then I would like to thank RIPE and NC also for letting me sponsor this trip and being here for presenting you this work. This work is called When Satellite is All You Need, is All You Have, Watching the Internet from 550 milliseconds. And it's a joint work between Eutelsat and my home university. So this work was initially presented at IMC in 2022. So first, why do we want to study satellite? Well, because in many situations, satellite communication is the only way that customer can actually access the internet. For instance, because of the lack of the wired connection. And so satellite can be actually a reliable and very useful solution. How does it work? It works in a nutshell in a way that customer have an antenna that connect through satellite. And in this specific study, we focus on the so-called geo-satellite communication, meaning that the satellite is placed on a fixed point on Earth that is actually located 36,000 kilometers away from the actual antenna, so quite far. Indeed, to actually reach the satellite and send back the traffic to the Earth, just for this, the timing for the traffic is at least 550 milliseconds. Quite a huge round of time with respect to what we usually expect. And how does it work? It works that there is a satellite placed so far that is actually composed by a lot of directional antennas, where each antenna has a transmission beam that covers a huge area where thousands of people actually can connect through the satellite. Then we do have an infrastructure in which the terminal of the user is connected through the satellite equipment in the so-called customer premises. What this satellite equipment does, it manages all the link and access protocols that are required for accessing the internet and actually accessing the internet network. And given this huge round trip time and problem with the quality of a possible experience due to the TCP protocol and how the TCP window grows based on round trip time, we have that, and we will see more about it later, that the satellite equipment on the client premises also act as a performance enhancing proxy. Then what we have is that this parabola send the traffic through a UDP channel to the so-called ground station that is the first point on Earth where customer traffic land, and actually where, based on this UDP tunnel, in the provider premises that is here where there is the ground station open a new connection with the web server that the customer was interested in order to actually get the traffic and send it back to the client. But how does it work actually, this performance enhancing proxy? It works in such a way that all the physical connections are break in two parts. In the first part, on the left, on the client premises, what we have is that the satellite equipment actually impersonate the actual server, meaning that it breaks the three-way handshake immediately and answer immediately to the customer so that there is no delay between the first request and the actual act of the three-way handshake, and start receiving the data from the client so that the client can start asking for the content to the web server. This allows the satellite equipment to store the request done by the customer and send as fast as possible through this UDP channel, without waiting the TCP window to grow, to the ground station. The ground station, what it does, it will open actually a connection with the real web server that the customer was interested in order to collect the data and send it back to the client as fast as possible. Of course, not at the ground speed, because this will be too much for the satellite and for the customer, but actually based on the terminal of the user speed requirements that allows also for reducing buffer overflow of the ground station, since there are thousands of clients using this performance enhancing proxy. Other than that, what the ground station does is the NAT, so Network Address Translator, eventually DNS Resolver. We will see that in many cases, actually, customers decide to use their own one with eventual degradation in performance in accessing the internet, and other than that, quality of service scheduler in order to promote some traffic than other. So, based on this situation, we pose ourselves several questions. First of all, how does customer look like, since we monitor 20 different countries? How much customer consume from the provider point of view? What customer consume, which kind of services they access, if it's similar or not with respect to what we see in wired network. And lastly, what is the performance they get? For this, we had to establish a measurement setup where we have, on the left, all the clients that are connected through their satellite communication that reach our single ground station that was located in Italy, specifically in Turin. We actually monitor several 10,000 of customers located in 20 different countries, each one that having up to 5 megabits per second in uplink speed and up to 100 megabits of download on the speed. We set in the ground station a passive probe, a passive meter that monitored in a period of 3 months in 2022 about 34.4 billion TCP flows, for a total amount of 4.3 petabytes of client traffic, so quite a lot. As a passive meter in the ground station, we rely on TSTAT. TSTAT is a passive probe deployed at Politecnico di Torino that allows us to monitor more than 100 statistics for each TCP flow. So for instance, the client IP, which is anonymized for preserving any privacy, the client port, the server IP, server port, how much data were exchanged, packet loss, etc. Other than that, we know the protocol, and we do use a plugin called DNHunter in order to track the DNS conversation for actually downloading data for this TCP flow, and knowing either the FQDN, so the name of the server that was required, or in case of TLS, the SNI and the information of the certificate. We will use it because we need it for understanding what kind of service the customer was interested in. Indeed, as someone quite more famous than me, John Postel, in a very early RFC said, the name indicates what we seek. However, with the FQDN, we don't know exactly the service, but rather what was the server name that was required. So what we did, we evaluated over time the different names of the different services, writing regular expression that allows us to translate server name presented in the FQDN, SNI, and like into actually a service name. This allows us to understand what customer was interested in. This allows us to collect a lot of logs describing these TCP flows, and we translate this log into value by sending these logs to our data center, where in our data center we rely on Spark for doing big data analysis and extracting some of the answer I told you before. So without any further ado, let's see the answer. On first, how does customer traffic look like? So for this, initially we start understanding, okay, we have 20 countries, which one are the most populated one, and how much traffic is managed by every customer in this country. So here we have for the top 10 countries on the x-axis, the percentage of volume, so of the total volume generated by customers in that specific country, and the percentage of customers being in that specific country. What we see is that, for instance, considering Congo, Congo is the most populated country according to the amount of customers, and actually also for the volume point of view. This relation is not actually linear. Indeed, what we see is that the per customer volume is much higher with respect to what we see, for instance, in Europe, for instance, considering Spain, where we have a smaller fraction of user, and the per user consumed per day is 170 megabytes in Spain, while it is actually 600 megabytes per day in Congo. And what we imagine is that eventually it's also because in Africa country, the single customer is not actually a single person, a single end user, but rather that the connection could be shared among several customers, while in Europe we use mostly the connection when needed because we have no other option. Otherwise, we use wired connection. For better understanding the customer, next we evaluated the day pattern. So when actually customer generate the traffic. And what we see here on the top are all countries related to Africa, while here on the bottom, countries related to Europe. The y-axis here report the percentage of traffic on every time being with respect to the maximum amount of traffic exchanged in that specific country in a given time being. Here, what we see is that the pattern between Africa countries and European countries is very, very different, with Africa country using the connection basically every day for all day long, while European countries tend to use it more during the evening only. Again, this gives us an intuition that it's possible that the connection in this case is used for all the kind of usage, eventually because there is no other connection, while in Europe is mostly used during evening and leisure time if needed. Next, we ask ourselves how much the user consume, so how much the user cost eventually for the provider. And for this, initially, we started looking at the amount of TCP flows generated by every customer in a day. And here on the x-axis, we have the number of flows, and on the y-axis, the complementary cumulative distribution function. Solid lines are European country, dashed lines are Africa country. And again, we see a clear distinguish between these two continents. In Europe, we have that 50%, so these top ones, of the clients that actually generate less than 250 flows in a day. Basically, nothing. It means that these clients are highly inactive. If we look at the same 250, instead in Africa, we see that almost all clients generate such amount of traffic, meaning that in Africa, customers tend to be much more active. And so, what we imagine is that this internet access, again, could be shared by several devices. Unfortunately, at this stage, we cannot see what happened on the device side because we have access only to the ground station data. And eventually, it's because the same connection is shared among different household, business, or internet cafe, because the same customer generates much more flows. Is this actually the same if we consider the volume of data, if we think about the download byte? Well, for this, we will focus only on the so-called active clients, that are the clients that generate at least 250 flows in a day. And we depict again the complementary cumulative distribution function of the downloaded volume in a day for these active clients. Here, what we see is that for African country, 2 of African countries out of 3 actually handle more data per day, as expected from the flow size, but the increase is much smaller with respect to what we see in terms of volume. Indeed, in this case, the difference is just some gigabyte of difference. If we consider heavy hitters, so customers that actually in a day download a lot of data, what we see is that customers downloading at least 10 gigabytes a day in Congo are 8%, while in Spain 4%. Again, meaning that in Congo it's more likely that people will use it more, even heavily. And this behavior is important to be understood because eventually can be impacted the beam, so the area covered by these heavy hitters that eventually could saturate the beam capacity, causing some congestion, or even just the per customer experience since the bandwidth is limited. Next, we know how much they consume. How do they consume this data? What kind of service they access? And for this, we rely on the regular expansion I mentioned before to translate the server name that comes from the SNI of TLS, DNS query, or HTTP host name in the actual service name, translating, for instance, this into actual Netflix. Here, we have a first table for 3 countries in Africa, on the left, 3 countries in Europe, on the right, plus the average behavior. We focus here only on services that we can actually identify as services that were actively contacted by the customer because the customer wanted to contact the service. Just to give you an example, for instance, we do not consider for this specific result YouTube or Facebook because eventually you go to a news website and you contact YouTube or Facebook because of a social button or a video playing in background. So we focus only on those, on the popularity of the services that we can actually infer the customer was interested in. Here, we see that, of course, Google is pervasive everywhere in the world, not so much surprising. But if we consider chat, we see that, again, WhatsApp is the most popular one. And from our point of view in Italy, where Snapchat is not so much popular, was interesting to see that it's actually the second most popular social messaging application, which is highly popular in Congo and in Ireland. Next, if we focus on social media, namely Instagram and TikTok in this case, we see that actually TikTok, even though it's very newer with respect to, younger with respect to Instagram, is keeping the pace with a little difference in the percentage of customers using these 2 services. Lastly, regarding to audio and media streaming, we see an interesting result. For instance, if you consider Netflix here, we see that it's very popular in European country, in this cell, with a popularity, for instance, in Ireland of 50% of active customers using Netflix with this satellite communication, while this percentage highly drop in Africa country, for instance, only 17% if we consider Congo. Namely, customer looks like they use less this kind of paid service for their leisure with this kind of connectivity. But is it actually true? So for this, instead of focusing on the popularity of the services, we look at how much volume is generated per customer contacting these kind of services, considering all services, not only those one listed before, because if we consider the volume of services, YouTube as a social button does not consume much, so will not impact its distribution. And we report with boxplot the distribution of every country and how much the country consumes for a given category. For instance, here we have the boxplot for Congo describing the 95th, 75th median, 25th and 5th percentile of the distribution for consuming chat. Starting from chat, we see that there is a huge difference between Africa country, here the 3 box plot on the right, and European country. Indeed, if the median European consume is less than 10 megabytes per day, actually in Africa country is 250, much higher, with heavy hitter consuming up to 2 gigabytes per day just for chats. If we consider social media, the situation is quite similar, with a median usage less than 30 megabytes per day in Europe, while in Africa grows of an order of magnitude, for instance, in Congo. So actually they use much more this kind of service. Instant string, video streaming, that was not so much popular according to the previous graph, has a median value very similar across the different countries. Why? Because in the previous graph, we focused mostly on paid services for which we were sure the customer was interested in, while here we have included also free softwares, free services such as YouTube, and we saw that in Africa, most people use this kind of free solution rather than paid solution. Lastly, we focus on performance, and we focus on performance initially focusing on the satellite round trip time, so the time for the customer from the customer premises to the ground station, and we compare the distribution with this violin plot of the night time, where there is supposed to be no congestion, and this line depicts the 25th, median, and 75th percentage of the distribution, with the peak time, where there might be congestion. As expected, the minimum value is about 550 milliseconds everywhere, and grow up to more than 2 seconds, quite a huge round trip time, and a huge delay in getting the content. Spain and Nigeria, so this violin and this other, show the best values since they are quite squeezed on the bottom, while other, such as Congo, show a distribution that is spread across also higher value, and specifically in Congo we see that the median during peak time is much different with respect to the median during off-peak, possibly pointing to some congestion. And lastly, we see that Ireland has a distribution that is spread up for all non-peak time and peak time, so eventually this is not due to congestion, but rather some location problems. For further understanding if it's related to congestion or not, in this plot we have the beam utilization on the y-axis, where the beam utilization is evaluated with respect to the maximum beam utilization over all beams, and the median satellite round trip time in that specific beam during peak time. What we see is that in Congo, regardless the beam utilization, the round trip time tends to be on the top part of the graph. What does it mean? It means that eventually Congo and Ireland suffer from high delay regardless the beam utilization, and by discussing this with the provider, we discovered that this congestion is not actually on the satellite communication, but okay, hold on, just some touch, some press. So it's actually related to some congestion on the prep premises that has limited capacity for every beam, and this can eventually be handled by the kind of class and quality required by the customer. Lastly, we focus on performance regarding to DNS. So here we have the DNS popularity of top DNS resolvers based on country, and what we see is that the operator DNS is actually not much used, if not in Europe, while across other countries, such as in Africa, other DNS are very popular, such as Google, but also other DNS resolvers, such as, if we consider Congo and Nigeria, we see that there is a Nigerian DNS resolver or even a Chinese DNS resolver. And this result, if you look at this number on the right, that if I want to access DNS resolution, in one case I may take 4 milliseconds only, because it's actually on the ground station, the DNS resolver, or up to 350 milliseconds, quite a huge amount of time just for getting the DNS result. So this means that getting the result as DNS may impact the performance in getting the response, but does it mean that also on the final performance I will get any impact? For this, we focus on some services, for instance, this captive.apple.com, and check to get the traffic from this service. How does it take based on the DNS resolver I use? And what we see is that actually there is a huge difference. In particular, if I use a Chinese DNS resolver, in this case, to access the content of this specific URL, I may take more than 100 milliseconds if I use this resolver, while with the operator DNS resolver, it may take me just 23 milliseconds to actually access the same URL. So the DNS resolver impact with the CDN that I'm going to use and my final performance. So for concluding, what we have seen briefly is that different customers have different patterns across the different countries. African countries eventually share the connection, the internet access among different end users, while in Europe, we use mostly the connection if needed, and we have no other option. European countries use more satellite during the day, while African country, while Europe use only during the night and leisure time. That the satellite round trip time does not depend only on congestion, but other situations as well. That the DNS resolver plays a fundamental role in evaluating the performance. And as a future work, we would like to use IPv6 to actually understand if there is this connection sharing phenomena in Africa, and eventually study QUIC and other UDP-based protocol, how they changed over time. So thanks for your attention, and I'm pleased to answer any question.
Any questions? Thank you, Danilo, for your time and your presentation.
Thank you.
Next up, we have Daniele Arena, the presentation of finding the locations of CDN servers. Sorry.
Hello. Do you hear that? Yes? Okay, so let me find the right clicker. Hopefully that's the right one. Hello, and welcome to yet another research made by Italians. Less charts, but more maps. So, okay, my name is Daniele Arena. I work for Namex, and I did this with Max Stucchi, who is a long-standing member of the community. Most of you, I'm sure, know him. So first of all, what is Namex? Namex is the largest IX in central and southern Italy. We have 5 sites in Rome, 1 site in Naples, 1 site in Bari. And we also have a collaboration with RASH, the Albanian academic network, for the IXP that they have in Tirana, which is Annex. Namex has 700 gig peak, 238 connected networks, established in 1995, but we're not really here for Namex. We're here to present I'm here, but Max cannot see us, but hi Max, because this is being recorded, so you will see this later. We did this, but this is work in progress, so it's not a scientific research like the Politecnico di Torino. There's a lot of things that still need to be done, and the last slide will be on this, and it will be on asking for your feedback, because we're trying to figure out whether this is useful, relevant, whether it makes sense to continue. So a little bit of a background. What do we do with an internet exchange? What's our goal? Our goal is to keep local traffic local, right? We love low latencies. We love eyeballs close to content. And what we're trying to do is also try to figure out how to do this better and what the situation is. So doing some research on what's up with latencies and distances from eyeballs to content. So one of the great tools that exist is IXP Country Jedi. This is based on Atlas. By the way, if you don't have an Atlas probe in your network, please do get one. I'm sure that the RIPE and CC will tell you. And I was actually, I don't know, well, whatever. I'm actually an ambassador, but I forgot my probes at home, so I'm sorry I can't give you one. So IXP Country Jedi, what does it do? It basically runs trace routes between probes inside a country to figure out whether the traffic stays inside the country or goes outside. You can see from the map at the left that the latest run in Greece has most of the traffic staying in Greece, but some of it just rambling through northwestern Europe, Amsterdam, London, Copenhagen, Paris. And on the right, you can actually see a chart showing the relationships between ASs and whether from one AS to another, the traffic actually stays in the country or not, and passes through an IXP or not. So this is great, but we have an issue, and we've been talking about it with Max for a while, and this is that there's a lot of content-related traffic. So just to give you a measure, in Tirana at Annex, up to 90% of the traffic, again, not a scientific measurement, but it's related to OTT CDN. And so the traffic between local ASs is a small fraction. So the question we had was, okay, so you are eyeballs and you want to get content. Where do you get this content? Do you get this content next door, or do you get this content next country or next continent? What is the cache that serves you? And how far is it? Of course, the CDNs know. You speak with CDN, they open their laptop and say, oh yeah, okay, so Albania, Greece, yeah, you get the content from here, here, and there. But this data is not public. And so ideally, what we would like is to have some Atlas probes and, doing trace routes to the CDNs. But that doesn't really work. And there are two reasons for that. One reason is that CDNs have their own dark magic algorithms that basically, everyone has their different one, but they find in some way what the best cache is for you. And if I trace route to, say, Netflix.com, I basically go to AWS in the United States. But if I really want a movie from Netflix, then they do something, and I get it from the cache, which is in my city or close. So this is one issue. And the other issue is that, unfortunately, and again, please get an Atlas probe, the coverage of Atlas is still lacking, at least in some parts of the world. Some parts are wonderfully covered. Other parts are not covered well enough, and a lot of ASs don't have a probe in them. So, racking our brains, we discovered that there might be one solution, and this solution could be proxy services. So, I'm assuming you all know what a proxy is. You go through them to get a web page from on the internet, and you don't go directly from your device, but you go through that proxy. And there are companies that offer this service, providing proxies all over the world, and their coverage is huge. I'm talking about millions of probes in some countries. But even in smaller countries, there are hundreds or thousands of probes, which have a pretty decent coverage. And I'm talking specifically about residential or mobile proxies. So I'm not exactly sure how it works, but they're basically embedding the proxy in some kind of app or game that you download. And that's, you can basically use this as the proxy. So the coverage is there. And the other interesting thing that you cannot really do with Atlas is that you can ask for a web page, because that's what proxies do, right? And in several cases, at least, CDNs actually embed the location of the cache where you're getting traffic inside either the HTTP header or the HTML content or both of the page you're looking for. So I'm put some of the companies, Oxylabs, Bright Data, Smart Proxy, but there are several more. So just to show you how, what we did. What we did was trying to get, for example, let's take Greece. We get all the proxies for all the all the autonomous systems in Greece. And for each proxy, we try to get the web page where we know that this, the location of the cache is embedded. And the location of the cache is typically a city or airport code. So this is an example that I made by hand. It's not an actual research. But ATH, for example, is Athens, the Athens airport. VIE is Vienna. AMS is Amsterdam. So with this example, we're trying to get the magic URL and from 4 probes, and one proxy gets the content from Athens, another from Vienna, another from Amsterdam, and the last one from Athens. So we tried to collect this data like this, and we tried to collect it. Well, we did collect it for 3 CDNs so far. Cloudflare, Google, and Netflix. And what we did is we selected a country, we took all the ASs from that country, and we tried to find a proxy in each of the countries, and in each of the ASs, sorry, and then we get the web page and we extract the location. So we analyzed this, and we did maps that you will see later. But the other thing we did is we tried to weigh it by population. So APNIC, I don't know if you're aware, but they have a long-standing research that tells you what's the customer population for each AS in each country. So we tried to figure out what's the, for larger ASs that have a larger number of amount of customers, and smaller ASs where they get their content. And then visualization, of course, we created some maps of the links. And this is what we got. So on the left, you get the map, you have the map of IXP Country Jedi, and on the right is our current, quite rough, web interface. So here you can see the CDN locations of Greek proxies, and you can see that these Cloudflare, and you can see that these Greek proxies get their content from the yellow dots, which are Athens, Belgrade, Sofia, and Bucharest. This is an example for a run that was made on the 9th of April through a certain proxy service. And so I took as examples, and this is the maps intense part, I took for each CDN, I took two countries. One is Greece because we're here, and one is Albania because it's the one I can most relate to, because we have Annex in Albania, but also because they have quite different setups. So I'm rather confident you're seeing the maps, much less confident that you're seeing the charts, but I'll tell you. So for Google, you can see that there's 4 places where Greeks get their content, which are Athens, Milan, Frankfurt, and Sofia. But from the chart, you would see, if that would work, that practically all the content is actually taken in, oh, there's also Thessaloniki, is in Greece, either in Athens or in Thessaloniki. In Albania is rather different. So yes, most of the content is taken from either Tirana or Pristina. Pristina is considered Albania. I'm not going to get into that. And then the rest is about 20% is taken from Belgrade. Things get a little bit more complicated for Cloudflare, whereby Greece still has most of its content taken from a server, Cloudflare server in Athens, and some of it from Bucharest. while you can see Albania goes a little bit all over the place. So Tirana is a very small part, but because there's no IXP there's no Cloudflare server at an IXP in Albania. There's only a Cloudflare server at one specific ISP that I know of. But the rest is taken from all over. Sofia, mostly from Sofia, Prague, and Budapest, and then Belgrade, Athens, and Vienna. And Netflix is also rather complicated, whereby Greece gets all their movies from Greece, and Albania, not really. Even though there is a cache in Tirana, it's definitely not used by everyone, so only a quarter get their content in Tirana. It's true that about 40% get it in Pristina, so I can assume that these are Kosovars. But then it's taken also from Bucharest, Belgrade, Zagreb, etc. So this is the results, more or less, that we get. If you are interested in whatever country, whatever, if you want to talk, I'm here the whole day. You can ask me for a demo. You can ask me for your country. I have run this for, I think, all the countries in Southeastern Europe, also some countries in the rest of Europe, but it only takes 10 minutes, I think, to run one, so I can just run one if you need. So you can ask me if you want some information. But what I'm asking you and what I'm telling you is that there's definitely a lot more work to be done. Of course, there's a lot of other CDNs that we can analyze. Some of the CDNs in their web pages, in their HTML magic strings, they also contain not just the airport code, but also whether you're taking this from a specific ISP or from an IX, which is also very interesting, but we didn't go into that. SCE countries are rather small-ish compared to others, but for larger countries like Italy, Spain, Germany, France, there are multiple IXPs, so you can filter by city region, which is also something that the proxy services allow you to do. So this is also another thing. Integrate some DNS analysis, whether if the resolver changes, does the situation change? We haven't done this yet. In some cases, the web page doesn't give you explicitly the city. So maybe it's possible to emulate a browser inspector, but this is way more complicated, so we didn't do it at all. The next step might be actually the last I wrote here, to try and establish some measure, because as you saw, the traceroute in IXP Country Jedi actually shows all the steps. I mean, all the steps that the trace can identify. So we would love to try and understand more about what's the distance between the actual proxy probe and the server. So we think we could do some traceroute through SOX 5, maybe, but we haven't tried at all, or at least do some measures on the distance of between the AS of the eyeball and the AS of the CDN server. And this is why I'm here, to please roast me, tell me that this is completely useless, or whether it's useful, and whether you think that there are some reasons, some ways to continue this. And that's it. Thank you.
Can I? Questions, okay.
Who
I'm
are
bit
you?
fast.
State your name and affiliation.
Okay. Aren't you null? Good luck to anyone that can pronounce that right. Zeron company. So regarding the CDNs and their location in the global aspect in different countries, since I'm from Turkey, I have a bit of special interest in the censorship and whatnot. I am I would be interested in understanding different countries, different censorship laws there are. Since European Union countries is not much of a problem, I believe, because of the EU regulations being all the same for EU countries. But in Turkey, Cloudflare has opened this server, their data centers in Istanbul in 2018 or something. And I haven't seen any countries in close proximity using that data center at all. And I think this is because of the censorship, because when you connect to this data center from being in Turkey, the websites that are blocked by law, you can't actually access them. You can't access them through the Cloudflare CDN. So if there's a domain, FQDN, that is using Cloudflare's CDN services, when you try to connect to that domain, you see, oh, Cloudflare Istanbul data center working, but we can't access this website. It's down. So I'd be interested in you doing a demo where we can see whether or not any country other than Turkey connects to this Istanbul data center. Thank you very much.
Thank you. I can tell you I haven't run this for Turkey. I have run it for most of the, I said the SEE countries. I haven't seen anyone go to Turkey. Okay, but I can run a demo for other countries if you want. Just let's talk later. Okay, Daniel.
Hi, my name is Daniel Karrenberg. I'm the first and a current employee of the RIPE NCC. And Daniele is also a former employee of the RIPE NCC, so
Indeed.
I'm always proud when I see people doing great things, and what you do there is fascinating.
What I was about to say before is that I was there in 1990 something when you presented test traffic in Maastricht, and that's why I joined the RIPE NCC.
The predecessor of Atlas. But coming back to your project, I think the idea is fascinating. I think it's good data to have in the open, and you asked for suggestions, and I think what I would do if I were you is to try to make this a collaborative effort of probably the IXPs, because they're interested in this stuff. So I think you should go to EuroIX or something, or start small with some friends. I mean, never mind. But what I would like to see is that it becomes a collaborative effort, because it doesn't scale if just one person or one, even with Max. I mean, make this a collaborative effort. See how you can sort of make a data format that you can exchange with others, and try to build an ecosystem of people who make analysis from this. This is what we try to do with Atlas, and I think you could do something similar with that. I think there's a lot of interesting data there and also useful data there. So please continue this.
So thank you, Daniel. I agree, and this was really meant to be at least a prototype to see, the feeling and whether it makes sense. One of the obstacles of scaling it is that you have to actually pay these guys with real money, not Atlas credits. It's not a lot of traffic because it's just megabits, and they deal with, it's $8 per gigabyte. But I agree, if we want to run this for every country in the world, every, I don't know, month, week, if we want to do more probes, etc., definitely this has to go beyond Max and myself.
Yeah, no, Atlas is also paid by real money. It's just not, and that's why I'm saying make it a collaborative project, because I think there are some big IXPs, I won't name them, who have more money than is good for them. So let's try to funnel this into some of into activities like this. Otherwise you won't get it to scale. And I'm quite happy to help if I can.
Thank you, Daniel.
Hello, Antonius Chariton, unemployed. I'd like to ask you about a specific map that you had with Atlas probes, where one of the cities in the middle of Greece, I think, was going to the Vienna points of presence. My understanding is that out of the 3 large telcos in Greece, 1.5 does IPv6, for example.
This is just an IPv4 map.
Okay, I wanted to ask first of all about that. This is just IPv4, not IPv6.
There are, I don't know if you have, but if you don't, I think it's jedi.ripe.net, someone at RIPE NCC. Answer me. I think it's jedi.ripe.net. Jedi like the Jedis.
Okay, yeah.
And you can find all the countries, and you can go inside, and you can see there's 2 maps like this. This is IPv4, and usually a very much deserted map is next to it, and it's IPv6 separate.
Okay, thank you for the first question. The second is, like, do you clean up the data somehow? Do you apply some methodology to remove the data? Or do you rely on the later maps that have volume, and then hopefully all of these oddities will go away?
Wait, are you talking about Atlas, the left one, or the right one?
The right one later.
Okay.
Yeah.
I don't clean up the data. There's a lot that, as I said, it's not a scientific research. I take 1 probe for each AS, which is absolutely not scientific, because that probe might be today, I don't know, using something else because reasons. So yeah, absolutely. This is one of the things that's not just scaling, but it also, I also need, and we're in Rome, we have relationships with universities, and you know, after this, I'm going to also bring this to them and try to make it a little bit more scientific. So no, really proof of concept, really something that I wanted to see, and it seems to spark interest, so thank you.
Can I just answer the question? You know, Jedi.ripe.net is an FTP server with the raw data. So.
Oh yeah. Okay.
but all these maps are on the left-hand side. You can find on the RIPE NCC website by going to RIPE analysis, IXP country Jedi, and you'll find those.
Okay. Good. I use Jedi.ripe.net usually. So. Thank you. Sorry.
Interesting work. I'm Isabel, a PhD student at Max Planck. I was wondering if there's any abnormality of fetching the content from a far geographical distance if we compare it to the BGP path. So was there any chance to look if there's comparing from where the content is fetched from CDN with the path that we have? So is there a nearby CDN in my city or in my country in terms of BGP path, but I'm still fetching the content from somewhere else?
It's an excellent question, and it's definitely not something that we have done. And it's a question whether we can do this because the proxies are HTTP proxies, and you cannot really do stuff at lower layers. So I wrote, we'll try to do traceroute with SOCKS 5. I have absolutely no idea what results that will bring. I know it can theoretically be done, but I didn't do it. And so your question is valid and legitimate. It's definitely something, I mean, that's really why we started this. The reason we started this is why are people fetching content from other countries when there's a cache in your country? But I'm not sure we will be able to answer this, but at least we will work on it.
Okay. So do you want to answer something?
Yeah, well, first of all, of course, it's the secret sauce of the CDN. And if I'm not mistaken by talking to people from the CDNs, is they don't, it's a long tail distribution, they don't care about the tail. Yeah.
True.
It's the smaller you are in terms of eyeballs, the less they care about you. So having said that, one way to attack this would be to look at the ASs that have Atlas probes and see whether when you find your proxy in one of these ASs, take the Atlas data and correlate them, so you don't have to do stuff with SOCKS 5.
Correct. Yep.
That's and that's all publicly available data, so you could do that. Yeah.
Thank you.
Yeah.
And maybe a small follow-up, but slightly different. I was wondering if we do such a measurement continuously over a period of, I don't know, weeks and months, does it change from where I get the content, or is still the same city or the same city? And
it changes.
Any insights?
So
what
again,
influences the change, for example? Is there some live event, for example, yesterday we had, like, if there's a live match going on, the traffic pattern increases?
I've looked at this anecdotally for my own interest, and not scientifically at all. And yes, it changes, and it changes sort of at non-intuitive moments. And my guess is it has very much more to do with the back end of the CDN. They might actually take offline some stuff for maintenance, and then things change. So it's opaque why, but the changes are sometimes happening. Yes.
Okay.
So yeah, but to answer, I don't have the answer. I've run different measurements in successive even days, and the results are different. Not sure why. It seems to me that if you see the charts, the pie charts, the results seem consistent with what I know of the countries when I run them for different countries. But again, not a scientific thing. So another thing to look at.
Thank you very much.
Thank you.
Yeah. Last question, please.
Vasilis Kotronis, Thousand Eyes. Thank you very much for the work and presentation. So one idea for future work would also probably be investigating diurnal patterns during the day, depending on the cost, of course, of running the measurements, and see if this changes as servers get loaded during the day and users use them. And another one is also if this can run on demand before, during, and after an outage, for example, where content has to be fetched from further and further. If, for example, there's an outage in Athens, it makes sense that other cities will be used. Or even used as a signal for outages. Mm-hmm. So thank you for the work, and yeah, just some ideas for future.
Thank you for the ideas. For the moment, this runs when I put enter on Linux shell. So yes, it can be run on demand, but no, when we try to scale this up, we'll probably have to figure out how to do it. So sorry for taking up so much time. Thank you.
Next up, we have Antonios Chariton. I don't know how to pronounce, please correct me, regarding global IP routing for Kubernetes clusters.
Yeah, thank you very much. After the two Italian presentations, we're going to have a Swiss one now. I'm Antonios Chariton. For the past years, like since the last year's Google layoffs, I'm unemployed, which means hopefully you have a lot of free time and you can do something productive with that time. And this is that you can set up cool things and play with them, and maybe, you know, come up with something useful to present to your peers out of this. So before we begin, there is a warning. This presentation contains IPv4, which is known to cause controversy and polarize communities in the EMEA region. Please deploy IPv6. Thank you. But really, deploy IPv6. It's going to be very useful. So let's begin now with that. Let's paint a picture of what we're working with here. Let's imagine we have a network with a few points of presence. We've been to a few data centers. We rent a few racks there. We have IP routers. We have transit providers, internet exchanges, all sorts of connectivity, and we have a backbone connecting all of these services. Maybe we're building a content provider, which is relevant to the previous presentation. And in these data centers, we typically have some servers. We need some processors, some RAM, some storage to serve content to the users, or to find a way to offer our services to them. And in these servers, you run all sorts of professional corporate services there. So you may have like web servers that are caching content. You may have like your own custom applications that your developers are writing, and you want to deploy that all to your servers. For whatever reason, you chose Kubernetes for that. We're not going to go into whether this is the right choice or not, but there are certainly benefits, there are trade-offs, and a lot of companies seem to be moving to Kubernetes for such setups. We're going to assume for simplicity here that you have a single cluster that's operating across these regions, but this can work in federations of clusters or independent clusters completely. This is not dependent on how you set up your Kubernetes cluster. Now, in any service, you're going to have some of your applications that have to expose to the internet. You may have your authoritative DNS servers for all of your domains. You may have your web servers that are reverse proxying all the infrastructure inside, or even websites outside that. And it could be also weird applications that are using UDP, for example. So it's not all easy and nice here. So let's take a 3-node cluster to make this easy. Let's assume we have 3 servers in 3 different countries that we're serving traffic from. We have Nginx that we want to expose to the internet. And we're running 2 copies of Nginx for redundancy, load balancing, whatever the reason may be. So if we want to host 100 domains, we go to all of the domains there, we set up some DNS records to the IP addresses that these servers have from their local area networks. And so now everything is working, traffic can be served. The problem is that eventually one of these servers could go down. It could be software updates, reboots, power failure, hardware failure, whatever that may be. You're going at some point to have some server go down. But now, like the DNS records are still pointing to the other server, this is bad. Like now we're dropping traffic, we're causing delays, depends on client behavior, this is not good. So someone, like hopefully automation, maybe humans are going to notice this, that the server is down, and they're going to change that record because they will ask Kubernetes, okay, where is Nginx running now? Yeah, I moved that to Amsterdam where it has spare capacity. Okay, great, update the DNS record. The problem is that things are still broken because we have to wait for the TTL. If you have like long TTLs, you're going to have a lot of problems. And we needed to come up with a better solution for this. And Kubernetes has some software, some open source software. It's called MetalLB for load balancer. And this software works in the following way. The first thing you do is you go to all your servers, you set up a BGP session with your routers in that local area network. And if you have like 100 servers in Zurich and 2 routers, that's 200 BGP sessions you set up. And the reason you do that is so your servers can now advertise IP addresses to your routers, to your backbone that you built earlier, and they can also withdraw IP addresses like if they want to. And the next thing you have to do now is you go for every service, you find the documentation, you paste that into Kubernetes, and there are 2 things you need to note here. The first thing is that you set up a new IP address, and then you map that IP address to a service. What this means now is the following. Each server has their own IP address as before, but now, wherever Nginx is running, or wherever the other services are running, DNS, they are attracting their service IP address, like 16.64 in this case. So if the Frankfurt server goes down and the container moves to Amsterdam, then the IP address will follow that to Amsterdam. It will be withdrawn from Frankfurt and it will start to be advertised to your Amsterdam routers. And this works with /128 for IPv6 and it works with /32 for IPv4. So you need 1 IP address per service you want to expose. And this is very simple. We just took some software, we configured it. It's not magic. But this gives us a very simple primitive that the IP addresses are not tied to servers or hardware or data centers. They are now tied to logical services that are running on top of that. We managed to abstract away all the complexity of a network, and our developers or whoever is deploying services, they don't have to care about that anymore. And now DNS records can be static. They could never change. So you can have cool DNS records like that, assuming you have enough IP addresses. Because these are the Nginx IP addresses, not the hardware IP addresses, they will never change. It could be like a zone file on bind that you change with Vim. It doesn't matter, it's probably not going to change. What can we do with that now? Let's assume we tell Kubernetes to run an Nginx container in every point of presence. Like this can be configured, or we can ask it to run one in every city or one in every country. And now we advertise this /24 and 48 into all of our transits, all of our peers. The traffic gets into our network as soon as possible. So by BGP terms, of course, right? The traffic gets into our routers. There's probably an Nginx server running in the same rack. The response gets to that server, and then the request goes to that server, the response goes out. And now you can build like a cheap CDN, for example. If you deploy Nginx, you turn on caching. Now you can just proxy and cache requests across your network, and this is easy. The problem is that, not every service can scale horizontally. You're going to have services that have to run in a single location. You may have a database, for example, that you have to have a single copy of that running. You can't have like 5 databases. Or you may have, you deployed a few applications that you built, and they're running in like, you have 2 or 3 copies of them running. You don't have to run one per data center. They are not latency sensitive. They are not maybe that important. You can just deploy them into 2 locations, for example, here. What will happen now with that is the following. If it's an important service that's running, and you put it in the /24 that we used before, your network is going to pick up traffic from anywhere, and it's going to get that to that service through your own backbone. So if you are in London, for example, and I have presence in links, I advertise that prefix in the route servers, I pick up the traffic from London, and I have to carry it through my own backbone to Zurich, where the service is running. And this means that I have the predictable latency of my waves. This means that I know exactly the congestion of every link because I have it on Prometheus. And I have a very fine control of how the traffic is being routed within my network. The problem with that is that it's expensive, like buying all of this backbone capacity across Europe or even like transatlantic and whatnot, it's very expensive. It's not something that anyone can do for everything. So you may have some services that are less important, and let's assume they still run in Zurich. What you can do now is you can put them into a separate prefix, a different /48 or /24, and you only advertise that in Zurich. What this means from the person in London now that wants to connect is that they have to get the traffic to Zurich somehow. You're not responsible for it, although you have a connection with them in links, in London, whatever that may be, and you also have a connection with them in Amsterdam. You don't carry the traffic. You only accept this traffic in Zurich, and they have to carry it there. Now you don't use your own backbone. That's very cheap. Someone else has to pay to get the traffic to you. The problem is that, the paths could be congested, the latency could be high, like someone from the UK could send you traffic through New York. And now you have 200 milliseconds within Europe. You have no control over that path, and it's a worse quality for the user. Obviously you can make that groups. For example, if you have high enough capacity between Geneva and Zurich, you can say, just bring them in Switzerland. This is fine. I can carry them from anywhere in Switzerland to Zurich. Like dark fiber is cheap. This is fine. But I don't want to have to carry them from London. And these groups will be important here because they can represent anything that you want, any sort of grouping you want. Maybe you have regulatory groups. Like you have the EU group, which removes the UK from the map, and Switzerland as well. And you only accept traffic for these websites from within the EU. So you can go crazy if you have like a larger network. You can have the North America group, the East Coast or West Coast. Like this depends on your network, your needs, and the situation you may be in. Of course, like you've probably noticed that we need IP addresses for that. If you do the Anycasting, so if you're lucky and you have horizontally scalable services, you need one prefix. You stuff everything in there, everything's great, you advertise that everywhere, and things are good. In the important services, the more important ones, you can reuse the same prefix, because what matters for IP addresses is the foreign policy, what you advertise outside your network to your BGP peers, to your transit providers, to all the other networks. So if you advertise this network anywhere in the globe, the global group, let's call it, then you can have basically one prefix that's being used for that, to conserve IP space. And for groups, you need one per group. So don't go crazy, don't create like 1 million groups. Try to think use an engineering approach to determine which groups are relevant for compliance, for traffic reasons, for whatever the case may be. Now you're going to say that IPv4 is expensive. Thankfully, we have like brokers sponsoring these events. But my solution to that is that you can just offer a better service over v6. And you know, V4 they have to live with that. Like we can't use any technology to stuff more bits than 32 in IPv4. So you know, let's move into an IPv6 first and IPv6 better experience, and we can worry about IPv4 later. Still, like for some services, it could be 50% of your traffic, so you can't ignore IPv4. But you can do a more fine-grained control over IPv6 if you don't have enough /24s. Now, can we use DNS in that? Like a lot of the Akamais and the CDNs of the world, they use DNS somehow. And the DNS, like what it can do in this model is that it can move a domain from one group to another. For example, if you have a domain in the global group, you can move it into the Europe group or the Switzerland group by changing the IP address. So the Nginx is listening to all of the addresses, but DNS is only sending traffic to the group that you want it to go to. And this can give us a lot of flexibility. We can do a lot of great things with automation because of that. Let's see what, like the best thing we can do, the most useful for a content provider that has to distribute this efficiently, is we can have much more control over our traffic and the paths it's following and how it's going. So the DNS can move us between groups in TTL seconds, and the groups can be defined in BGP, and they can be globally reachable in less than a minute. So we can now, if we have some metrics from our network, like we have the link utilization of our backbone, we can make decisions and move services around. If we have high utilization, we can just move a few services to a different group that's cheaper and does not consume too many of our resources. And that means we can just offload some of that traffic, have others carry it for us. We don't pay for it. We sacrifice a few things, but it's for the overall benefit of our users and our network. Now, if you make too many changes, you need to be careful of a few things like ROAS. If you deaggregate space, you may not have a covering ROA, so you need to take care of that. And your route objects, of course, for whomever is using them still. And you may have prefix limits in your exchanges. Like you now advertise only your /16, and then you try to create 10 groups, you reach the prefix limit, your sessions are down. This can happen if you don't have sufficiently high prefix limits with all your neighbors. And of course, flap dampening, if you keep advertising routes, then withdrawing them again, like someone can turn off that session because it's causing too much trouble for them. If you're doing this too often, if you have like a very eager system to move services around, it could cause issues with your sessions, and if you're creating too many groups without careful thought. For example, in my case, like I use peering DB. I publish my prefix limits there, But when I set up a private BGP session with someone, they look at peering DB and they say, okay, like, sure, 64 or whatever. I'm going to configure that in the session. And then, like, for the next 5 years, they never touch it again because it was manual or their automation accepts the prefix limit manually. And even though I change peering DB, unless their automation is built to detect that and reconfigure the filters, I'm going to have the old prefix limits of when I turn the session up, and it's going to then be very low. And there's no way to learn the prefix limits that others impose on your session, so it can lead to surprises. You have to inform people manually. It's unfortunately a tedious process. My recommendation is try to determine the groups that make sense ahead of time and set a high enough prefix limit. There is a difference between 100K and 200K, but there's probably no difference between 32 and 128, for example. No one's going to notice that, and it's not going to cause too many problems for people. Now let's see what we can do. This is the most interesting thing. This involves collecting all your services in a list and setting some priorities. You can say the web traffic I'm serving is very important. I assign it 1,000. The numbers are arbitrary. Like Grafana is also important. I want that exposed as well. Or, you know, like the DNS service or whatever. I'm running some Debian mirrors to help the community. These are less important. And then there are personal projects people are running in the infrastructure. I don't care about them at all. So let's imagine you have this network. What you can do is you can serve every service globally. Like you want to have Nginx in the prefix that's advertised across your sessions. You're drawing traffic to it very soon. It's going into your routers. It's getting served in the closest point of presence. And then when your alerts are firing, you configure these in Prometheus, for example, 80% utilization in a backbone link for like 5 minutes or whatever you want. Or you can use NetFlow, SFlow for that. If you have a real-time or near real-time pipeline with flows, this is something you can use as well. So you can also get a per-service utilization of every backbone link in your network because the service IP addresses are static. Now, if you have, for example, a link that starts to get close to full, what you can go is you can go through your list. Okay, what's the list, like the service with the smallest priority number? Okay, it's the personal projects. I'm going to move this into another group. Like you use DNS, the server has an API or something like that. And you change the IP address now to the static IP address of the different group that only advertises this prefix within this ring we have, and this remote node is not participating in it. So if, for example, this ring is in Europe and this remote node is in the US, and your transatlantic cable starts to get full, you can start offloading traffic from the least important to the most important. And if you're having a bad day, you know, multiple backbone links start to get utilized, then you can keep moving more and more services away from this global group. So when everything is fine, you can provide the best experience for your users, get the traffic, carry it yourself, but as soon as things start to get problematic, you can start offloading things one by one from the least important to the most important. And the good thing with this is that you can, if you have metrics from other parts of the internet, you can plug them into this as well. If you know that you know, this cable from Cogent is having a bad day, you can try to route around it if you have a significant presence in your network. And this could explain in the previous presentation why, you know, the things change so often. Like routers have issues, cables have issues. If you can somehow detect that from metrics within your network, you can use DNS, you can create the right groups to try and steer around that. Using filters, using the right prefix combinations, you can find ways around outages. So if you have a big enough network and Greece, like one of the Greek providers, is having a problem, you can try to alleviate that by moving traffic in less congested links, even though they're not your own. Obviously, this is a bit more difficult. You need like a lot of visibility and presence for that to happen. So let's talk about group creation. The easy thing is you define your groups in a meeting room or over email, and you add them to your routers, statically configured. They never change. They have the same meaning all the time. You add that to DNS, like to your DNS automation tool, and everything is fine. If you're feeling more adventurous, you can use dynamic groups. Like Metal LB, the software we're using, it can basically advertise as /48 or /24, so it is globally visible. You don't configure these groups in your IP routers. The servers will be attracting them for you. And this will be publicly visible. Like you can hide the private AS or you can use confederations, but everyone from the outside will see this /24 originating from your AS, and now groups can be created dynamically. This is more dangerous, like you can run into prefix limits and all of that. You may have to make a more difficult configuration in your DNS servers, because now groups don't mean anything on compile time. They mean things on runtime, and this can change. But it's something that you are allowed to do. And now for incoming traffic, obviously you need to balance your connectivity. If you have like a transit in Amsterdam and Athens, it's generally expected that you would have much more transit traffic that's arriving in Amsterdam than in Athens. So if you count on Athens picking up the slack from Amsterdam, you have to be aware that, it's going to not double in traffic. It could go 10x higher in traffic. And if Athens was 90% peering, it could now be, 5% peering and 95% transit. So the balance across your network may change as well. And, maybe Athens will go down as well if something like that happens. There is one more quick thing before we get to questions. Quick announcement. In the few minutes we have remaining. To improve connectivity, me and a friend, Pim van Pelt from Switzerland, we're building a free internet exchange here in Greece. We have 2 points of presence, one in Thessaloniki, another one in Athens. We are providing 110 and 25 gigabit ports for free. You can send us an email even if you're not in one of our data centers yet. We're trying to help improve the peering situation in Greece, keep more of the traffic local. So if you want to join, if you want to learn more, send us an email. Even if you're not currently in one of the data centers, it helps us to know which data centers to prioritize. And this is some project, it's something that we do, it's not a commercial thing, obviously it doesn't generate revenue. So prioritizing is going to be important. So let us know. And to try to offer some incentive into joining, at least in the beginning, I hope in a more long-term nature, we have a free IXNet project. We basically have 100 gigabits from Thessaloniki to Amsterdam, and we are joining a few free internet exchanges there, and a few paid ones maybe. And we have an autonomous system that can help you exchange traffic with these exchanges, and we're offering that for free, up to 1 gigabit per second. And we hope that this will provide some, maybe partial transit, however you want to call it. That's going to bring over 300,000 prefixes from day one for those who want to use it. And that's all I had. Thank you very much.
Thank you very much. Questions? Okay. Thank you, Antonios, for the presentation, and it's time for a lunch break. Thank you.
See you.
Hello, everyone. Let's start. This is Vesna and Sanel on behalf of the PC. We are starting the afternoon session, which is going to be all about IPv6. We will have a presentation by my colleague Qasim from RIPE-NCC first, and then we will have a panel discussion with a lot of people on the stage. So without further ado, let's start. Hi, Qasim.
Hi, everyone. Hope you had good lunch. Good afternoon. So I want to talk about advancing internet technologies in Southeast Europe. And what I mean by internet technologies, it is IPv6 uptake in the region and routing security in context of RPKI. So if you have followed news in the past, you might have seen articles like this where SIG-NOC in 2022 asked the Dutch government or urged them to move their infrastructure towards IPv6 or adopt it in their network. Quite recently, we saw a post from Christian on IPv6 working group where he informed us that the Czech government has approved a resolution where they will stop providing government services over IPv4 starting from 2022. It's a bit far away, but nevertheless a really good news. We also saw Amazon changing their charging schemes where they will charge for IPv4 addresses, and I think these are really good news for the IPv6 adoption because it provides a good incentives for operators to actually start adopting v6. However, we are still far off. I like this example from the website called whyknowipv6.com, where it has the top sinners. These are the domains that are most or highly visited and still not provide IPv6 support. So in the context of Southeast Europe, we did a recent survey in 2023 and asked the operators of their IPv6 adoption. Half of the respondents said that they have actually implemented v6 in their network, and future readiness was a key motivation. They also pointed out few challenges, one of them being the feature parity between services that run on v4 and v6. I think the latter one, that is convincing decision makers to move away from v4, is a more important one and needs more thinking and motivation. So given that was the survey, we want to also see what we can observe from our data sets. So we look into allocations and routing data to see what we can observe about the v6 from the network standpoint. So overall, if you look at our members in Southeast Europe, we see Romania and Bulgaria have the majority of the LIR, or majority of the members in these countries. One interesting observation over here is Bulgaria has a quarter of the population of Romania, yet they have more members. So I would like to hear more from the Bulgarian community that why this is the case. We see this trend when we look at the IPv6 allocations. Over time, we see Romania and Bulgaria again leading with the more allocations. To look into more, then you see there are more active LIR accounts as well. So the total counts for LIRs for these two countries are also on a higher side. One possible explanation is if you look at the trend lines, you see there is a peak from 2007 until around 2021. This is the time we were running out of v4 space. So this could be actually a reason that there were more LIR accounts that were running towards, or more LIRs that were running towards the last bit of v4 remaining. So less to do with v6 and more to do with v4, unfortunately. We also wanted to see, this is just the allocations, and anybody who gets an account can request for allocations, but we also wanted to see what we can say from the routing table. And counting v6 address space is a useless exercise because the size is so vast. So we came up with a different metric. We call it IPv6 capability. And it is basically the percentage of an ASIS registered in a country that announce both v4, v6, or v6 pairs compared to the ASIS that are only announcing v4 space. This metric, of course, just to clarify, doesn't mean adoption. It just means that the address is routed. However, this is an important metric because it tells us something that there is an initial move towards an IPv6 broader adoption. Given the metric, we see Greece is doing really well. It's actually above the EU average, a little bit above, but still following the EU average. Albania, Montenegro is following them. And then again, as I said, Bulgaria, Romania, even though they have higher counts for the LIR accounts, they are falling behind for the V6 announcements from their ESs. Another interesting observation was when we look at this from the longitudinal standpoint, we see Greece has always been doing well in the past decade. And we see a very interesting trend where you see a peak around mid-February, March 2020. And somebody from maybe Greek academic networks can explain us what happened during that 1 week, because this is based on weekly data from RACE. So we see that academic ASs, so they are highlighted on the right side, somehow start originating the V6 prefixes. So now moving towards the routing security. I'm not going to go into detail of RPKI. I think there was some very interesting sessions yesterday which went into a lot of detail about RPKI, ROA, BGPsec. So just to recap, it's a two-step process, signing your own prefixes, that is ROA, and verifications of others, that is ROV. When we look at the ROA coverage over time, we see a big disparity between V4 and V6 address space. And one of the reasons we see this is V4 space is concentrated in fewer ASs or fewer providers, while V6 is spread across large number of LIRs or large number of ASs. And to get closer towards 100% coverage, for V4, fewer organizations need to start signing their prefixes or start doing ROA. Compared to V6, we need a larger proportion of networks to actually start signing their prefixes. Just to put this, illustrate this from the Greece example again, you see, for instance, OTE, when they covered their space with ROA, you see a jump from 25 to 60% for Greece for ROA coverages. Then again, there are a few jumps when Vodafone decided to cover their space with ROAs in Greece. So again, for V6, Greece, which is doing really well as well, but you see around 40% for V6. And the call for action over here is that ROA, signing a ROA should not be very difficult, and more LIR should be doing it also for their V6 space. And we should see some uptake over here as well for the future. Measuring ROV is not an easy step because you actually need a vantage point inside an AS to see if they drop invalids. We used a methodology called ROVista that was presented in IMC, Internet Measuring Conference, last year. I'm not going to go in too much detail about how ROVista works. I'm citing their paper in the references, so if you want to learn more about it, or you can talk to me after the presentation. But basically what it does is calculates a score per ASN based on RPKI invalid prefixes that the ASN can reach. It classifies a number between 0 to 100. We used a more inclusive approach where we classify AS as implementing ROV if the score is greater than 0. Again, that indicates that there is some ROV deployment for an AS. Another important way to look at this is not only see from the edge or stub ASs, but look more closely towards the transit AS for ROV. Since they are more crucial for ROV, so they can drop, if there is a route hijack, they can drop it and stop the propagation. To do that, we use another metric called AS hegemony. And what that does is basically find the centrality of AS in the context of a network or a country. So we use hegemony per country, and it gives a number from 0 to 1, 1 being most ASNs are dependent in that region on that AS. So given these two metrics, we come up with this picture. Here you can see different colors. So the dark blue colors are the ASNs that are registered in Greece and are doing ROV. and they are also very central to the Greek connectivity. The light blue colors here are, for example, 174 or 6939. Probably you guys know these networks. They are foreign ASs, so not registered in Greece, and they're doing ROV. The more important ones are the ones that are highlighted with the red circles. These are central to the Greek ecosystem, and they're not doing ROV. So a good example over here, for example, the GRNet is doing ROV, but for instance, NOAA, we see one of their AS is doing ROV, the other is not. Somebody from NOAA can clarify, but what I can see is the other AS, if I look at the AS name in Whois, it's Wind AS, and it's recently acquired by NOAA, and I think they might be updating the policies. The same trends we see for Bulgaria and Montenegro, where we see certain AS, so it's a mixed kind of a picture, where you see several ASs that are central to the connectivity of a country doing ROV, and while the others are not doing it. For Montenegro, the largest telecom is doing ROV, while all the other, which are very central to the country, are not doing ROV, and we have also missing data for one of the major ASs. To recap, while there are strides that have been made for IPv6 deployment, especially in the context of routing, but I still think there is a lot of room to grow. Greece aligns well with given the IPv6 capability metrics, but the rest of the region has to really do an uptake in IPv6 moving forward. RIPE NCC did a survey again for 2023, asking people for why or the reasons for not doing RPKI, and 52% said that it's the knowledge gap. There was a very nice tutorial yesterday. I hope you guys have followed it. It's one way to learn more about RPKI. And we also offer free courses to LIRs. There is L&D team here. You guys can go to them and ask them about the free webinars, trainings. We have a lot of nice RPKI courses that can help you move in this area. You can learn more. So there's the entire methodology, explanations, a lot more slides, presentation of how these countries look like in our article. So I hope you guys read the article. If there are any questions, please do reach out to me. Some of the references for the work that we used for our methodology are here. And yeah, if you have questions, please do let me know. I hope it was somewhat knowledgeable for you. Yes.
Thank you, Qasim. I'm Adonis Liomis, working for GRNet Greek and Ariane. Just an explanation why you saw back in 2020 this explosion in V6.
Sorry.
Is it?
Yes, this one.
All of our members are single homed to GRNet. So actually back to 2020, there was no actual need to deaggregate. But we thought that since we have members with public ASs, why not expose them to the public internet? And one of the reasons why was for the RIPE to have the ability to visualize connectivity to those prefixes. So that's why you saw there the gap. It was about, as far as I remember, 30 IPv6 prefixes that were announced. And we did the same for the IPv4, which was about 100 or something like this.
Cool.
So back then in 2020, we started deaggregating.
So it's the reason for the aggregation.
Yep. Yep.
Thank you so much. Yeah, that explains well. But thanks for the story. Yeah, I was really looking forward for somebody to actually explain this peak to us.
If you have a question, please go to the microphone. If not, then we thank Qasim once more.
Thank you so much.
Yeah. Next, I would like to invite the panelists to come to the stage, and Hisham will be a moderator, and he will take over from here, introducing the next presentation, presenter, and all the panelists.
Hello, everyone. Hello. Hello, everyone, and welcome to the IPv6 panel. My name is Hisham Ibrahim, and I'm happy to be joined by a panel of experts that will be sharing a little bit more from their insights about IPv6 and what they're seeing in the region here. We also would like to hear questions from you, thoughts from you as well, so let's make this session as interactive as possible. For the first part of the session, we also have a few slides. We asked one of our panelists, Vasja, that will be presenting now a question about what are the first steps that you need to think about and consider as an ISP when you're beginning to think about IPv6. It's one of the first barriers that we see, so we thought somebody that actually did the work can give us a good explanation on that. So, Vasja, please.
Hi everyone, I'm Vasja. I'm sharing with you our experience deploying IPv6 after the IPv4 ran out. We are running our little ISP on the northern east border of Italy, and we are in 2 employers and 2 owners, and mostly operate in Trieste province. We are RIPE members since 2021. What we did, we operate the ISP from 2018, and we inherited some customers from our previous ISP that moved away, and we continued the story, and we get the network already done, some part of it. So what changed till 2018, now we have around 1,000 customers, and we are able to sell now not only fixed wireless access, but also fiber to the cabinet and fiber to the home access, as well as any other services. So why we started to implement IPv6? First of all, why not? Because we had resources from RIPE, and were the only resources that we get, since the waiting list was very long, and it took around 10 months at the time to get our /24. We have to lease other /24s to start the business. And the main motivation was that we want to offer our customers some better quality of their services, of their experience. So that was the starting point. We want to get rid of the double NAT, the NAT on the customer's CPS and our NAT. So this was our main motivation. Also, the network complexity was bigger because we have to run NAT, and every node that you put in, it's a complexity. So, and of course, IPv6 is the natural evolution, and it's the future. So we proceed in that way. First steps. Just check our equipment if there were some problems. We saw that mostly all the equipment was supporting IPv6. There were some problems with our BRAS, NAS accesses. Not all were compatible. So we have to upgrade some part of the software, and then we were able to start. We deployed also all the internal essential services as DNS, local forwarders, and stuff like that. And that was the easy part. What was the main problems that we got when deploying, when we did the mass deploy to our customers? We saw that most of the CPS till now comes with IPv6 disabled by default. And this is not plug and play. So if you have a new customer, you have to manually do it. And some of our old CPS does not support prefix delegation, and neither /56, neither /48. We are delivering to all our customers /48 by default. We decided so, it's a ripe recommendation, and we have plenty of it, so we just decided this way. We also decided, by recommendation, to delegate statically all the IPv6/48, so that once the customer comes in, it has always the same IP, no problems for if he disconnects or something similar. We faced another problem, some local IT staff that is not used with IPv6, they just refuse to implement it. And we spent a lot of time convincing them that they should move on and adopt it, but it's a hard work. They should, but they have to understand by themselves when will be the right time to do so. There were also some vendor-specific problems that have been solved. The new software that we have to install, it's not yet completed. We solved the problem with the PPOS server, and the PPOS server had problem delegating blocks of IPv4 only in conjunction with radius, otherwise it's working. And also the backbone part is not yet finished, so there are some problems on MPLS, LDP, and VPLS, stuff like that. And accounting is not yet finished in IPv6 accounting. So it's in beta testing right now with the latest RTOS version. What helped us, why we need accounting, because by law in Italy we have to filter, we have to do DNS filtering for parental control. So we have to bind the addresses to the customers, and each customer have to choose what level of, the level of filtering that they want to be provided with. The main benefits. Since the start of deploying IPv6, we just saw that traffic flows to IPv6 naturally. And so we have a 20 to 30% of reduction of IPv4 traffic. So we reduced our traffic logs, and also the load on our NAT devices decreased. There was a performance increase because we have now only routed traffic, and there was a greater efficiency and failover because of the routing only architecture. And in one move, we get rid of 2 levels of NATs. And of course, it can be a business case for us. So this is just a comparison of the IPv4 versus IPv6 traffic. The blue one is IPv4. Please consider that only half of our customers is actively using IPv6. So by the end of the year, the IPv6 traffic should be around 40 to 50%. Mainly, the IPv6 traffic is coming from OTT providers, so Google, Amazon, Microsoft, and so on. What, for the end, our next ideas to deploy some tools for our customers so they can test their connection for the IPv6 connection or dual stack connection at home. We have to finish to migrate some services also in dual stack, but we have to have these services in-house. And we'd like to move our backbone to IPv6 only. And the other stuff is that we will be very happy if our VoIP provider will provide us with IPv6 VoIP services. In Italy, that is not so easy because we are one of the few providers that provide the customers with IPv6. And we have in mind to do some kind of promotional events like IPv6 days to invite all the customers with their equipment so we can set up it for them and just to promote the new technology to be spread. Thank you.
Thanks for that, Vasja. And when you submitted the slides, we really like that part where you describe, like step by step, what an operator needs to be do. Because in many of the discussions and conferences, people just say, yeah, just do IPv6. And then we find the operators going, I find all these barriers. So it was really great that you could actually describe your line of thought there. But maybe a question to you is, was it worth it, like going through all this for your company? Do you think it was well spent time and investment in getting IPv6 up and running?
We spent time and efforts of deploying IPv6. It's, of course, it is worked because we gain a lot of experience doing so. So we can use that experience to help others, but also to do business in this way. And the network complexity diminished as we have to do NAT and so on. And also we have 2 layers of networks that one can be resilient to the other. So if there is some problem on IPv4, we have still IPv6 that is running.
Another question is, you said you gained a lot of experience. Knowing what you know now, is there something you would have done different or started from somewhere else?
Maybe we will start before.
Mm-hmm. Very good answer. Thank you for that, Vasja. Now, when Qasim was presenting, he showed the figures from the region here, and Greece being very obviously showing very nice figures and very high numbers for the region here. And it would be very great if we could actually get some insight into that. And I'm very happy and pleased to have George here on the panel. George, if you don't mind introducing yourself and talking a little bit about the experience here in Greece.
Yes. Good evening, everybody. I'm Georgios Manousakis, representing OTE, the largest company here in Greece, providing all kinds of services in the telecommunications and not only. Actually, our story goes way back in time. We started working in 2004. Back then, there were 4 companies that eventually were merged. And in a funny way, they kind of work in parallel, even without knowing each other. Okay. So fixed started at the beginning, and then mobile followed. Actually, the international part as well. You couldn't get in the world in a different way. I was discussing this with Elena as well, trying to plan this, that what are we going to say again? We've been saying the same things again and again for many, many years in different panels. Anyway, currently, it's the default service for our customers is a dual stack service with private IPv4 addressing. We have some services that are IPv6 only, like the mobile IMS telephony. It's a common example. We are targeting launching the 5GSA fixed wireless access product, again using IPv6 only, plus NAT6 to reach before destinations. And we try to have our services also available in dual stack, both for our sake and for our competitors' sake, okay? to help our CDN and their CDN as well. What else? Our traffic is about 50% V6. That I would say it's less than I would expect, because most of the traffic is towards the big CDNs, which are all, of course, dual stack enabled. Only a few of our subscribers decide to stay back, if I would call it like this, in an IPv4 only world. And this is more often observed in the fixed world. And I believe it's a cultural thing there that lead us to this difficult future, let's say. Yeah, that's most about it.
No, thanks for that. And you touched at the end there on a very relevant point that I wanted to ask about, because you do provide both mobile and fixed services. And one of the points that Vasja pointed at when he was presenting is the CPE and their abilities to actually be able to do V6. And what I've heard from a lot of operators is V6 on mobile is easier because all the devices now are modern and they get replaced over time, whereas maybe some of the modems at the house are a lot longer and might not support the technology. Is that your experience?
Well, there are a lot of stories I could share about that. Mobile devices are easier because customers also try to get a newer device, a more expensive device, which more or less comes with the capabilities. But it's not that easy in the back end. So the devices are easier, but the back end is trickier sometimes. And we've been discussing about this many years. The biggest problem in the mobile world is the V6 only transition, not the dual stack. The dual stack was easier. The V6 only is it's a painful situation. Okay. In the fixed world, things are a bit different the other way around. Yes, indeed, CPs there are harder to find. We are in communication with our vendors to provide the software that we need to run. Again, I'm talking about IPv6 only, so I would dare to say it's the next era. Okay, so it's a bit different situation that you had to deal with, because we want to save our IPv4 space, which is really valuable. Okay, so we want to push our subscribers to IPv6 only. So yeah, in the fixed world, the CPEs are a little harder to deal with. You fix something, and then something else is broken, and go back and forth again and again. Okay, but it's not, as I mentioned it before, that in the mobile, it's so easy as it sounds. The terminals are, but in general, it's not.
No, fair enough. One other thing that we normally hear from operators is there's no demand from our customers for V6, so we won't do it until there's like a business case or there's demand. However, what you pointed out is that you proactively started working on V6 in anticipation for this happening. So just curious to what you would say to operators like that.
It's true. It's not an effortless job to do, okay? And it's not only the technical parts, okay? I saw this, your slides. I was feeling a bit romantic. They remind me my days 10, 15 years ago, trying to point out if some firewalls supported or not. But actually, in our days, the problems are more to distribute the information, to make your company aware, to educate the customer care, all the troubleshooting flows. This is way harder, okay? It's not the technical problems anymore, but and it takes time. Okay. I would say that the subscribers would never ask for it. Ideally, they shouldn't even be aware of it. Okay, that would be ideal. And this is the case mostly for the mobile users. Most of them don't care. They just want to have services to see their Facebook page or their Gmail or whatsoever, the TV content. And that's bridging with what I mentioned earlier in the fixed world. There are more needs. There are VPNs, there are corporate environments, and when you go towards this direction, it's a mess. They don't want it. They want to avoid it.
Thanks for that, George. Pavle, looking at you, other experiences from the region. Now, Montenegro has been trying to get IPv6 in the country for some time. I know you in the university have had a lot of efforts there. So maybe introducing yourself, your efforts that are happening, and what you're seeing in Montenegro as well.
Okay. Good afternoon. My name is Pavle Mijušković. I'm a Deputy Executive Director at the Agency for Telecommunication and Postal Services. So we are National Regulatory Authority for Electronic Communication. And on the beginning, I can still say that we don't have a mandate for IPv6, but we do everything to promote it. So our story actually started in 2019. Strategy for Information Society Development in Montenegro has defined some goals, and one of the goals was to do the strategy to plan for transition to IPv6 in Montenegro. So we hired a group of professors from the university. They did the job. They defined everything as professors do. We have the plan, how to do transition to IPv6 in the state in the state institutions. Also, we have one pilot project in the University of Montenegro. Actually, at the end of 2019, the responsible ministry, they established the IPv6 task force, and it was end of the 2019. Then, beginning of 2020, we implement the IPv6 on the Internet Exchange in Montenegro. We have to thank Jan George, who helped us to do this. 2020, it started to COVID, so we had to postpone some activities. In the beginning of 2021, we installed also IPv6 version 6 in our tool for measuring quality of Internet service, but it was just a start because nobody has an IPv6 address, but we tried to promote something like this. Then we organized 2 workshops on IPv6 with the ITU. Then in 2023, we finally got the lab for IPv6. We established this in the University of Montenegro. Then we one workshop with the RIPE-NCC Advanced. After we bring the Jan George to tell operator answer on all their questions about implementation. We did it also in 2023. And 2024, we established the NOC in Montenegro. So I think we do everything to promote IPv6 with engineers and technical people, but all the time, as they say, they don't have demand for this, they don't have business plan, and I think it's our last try to do something like it. Probably we have to include the government more than it's right now, because we have the steady investment in the sector. So last year was about 73 million, it's 10% more than previous year. We always have this increase in number of users, increase the traffic, let's say, in mobile, it's 41% per year, per user it's 30% per year. We have 5G coverage of population, 83%. They have 45% of the 5G phones in fixed also. We have high increase of 47% of traffic in total per user, 41%. 67% of connections are 100 megs and more. 50% of connections are on fiber. 80% of households have possibility to go 100 megs and more. I think we almost did everything, but with this IPv6, it's not going. They don't. I don't know why they don't want to implement it. So they say, let's say, this customer equipment, they have to change, but they increase the speed for, let's say, 400 to 1 gig, they have to change it if you want to have 1 gig per second the speed. Probably they don't have, I don't know, some cases, and also we have, let's say, right now it's 620,000 people in Montenegro, so it's not huge population, but right now we have the biggest problem with this law enforcement agency because we cannot identify the person uniquely behind the one IP address because of that, and that maybe can do something to speed up this, but I am not sure what else it can do.
Thanks for that, Pavle. One of the things that Qasim mentioned when he was at the beginning of his presentation is that the Czech Republic government mentioned or declared that they will be providing IPv6 only services by the year 2032, right? And they just said they're going to do that on their infrastructure. So they're incentivizing operators to do that, not mandating, not regulating, but saying this is our expectation to be able to provide services on IPv6 only. Do you think something like that could work in Montenegro?
But I think it probably be the only way, because I remember when they started, they say this Rome like a home in the Western Balkan 6 countries. It is signed agreement in 2014, and maybe by 2021 or 20 we have started to provide this Rome like a home. We always can find excuse because we have a COVID, then we have in 2022, we have the cyber attack on the government infrastructure, so we spend almost half of the 2020 and 2023 to, I don't know, to recover from this. But probably it will be only thing that the government say that they should start offering only services on IPv6. But when you look also at the DES index regarding this e-services, we are the lowest in 5.8. It's below the Western Balkan 6 countries. So also we have to offer more these e-services that probably that to train the government, the operator to provide this. But on the other hand, the state or the governments are the bigger customer in Montenegro. So probably they have the power to tell them, okay, we want this by certain year.
Thanks. And just looking at the slide that's being projected here, though Montenegro ranks 3rd in terms of percentage of IPv6 capable ASNs, because that's relative, right? So I'm assuming Romania and Bulgaria that are in the bottom of that list probably have more IPv6 capable, but because it's relatively speaking, maybe Qasim, you want to speak to that?
Yeah, right. That's true. Actually, the numbers, if you look at not the relative, but the actual numbers, then you'll, of course, find more. But yeah, the reason for having a percentage is just to see from the relative count that what we see. And in that regard, I agree. Another thing which I was just following on the thought is the incentive structure. And like at least the work I've done or seen so far, like there are people, the operators want it. IPv6 has been talked so much over so many years, but I still think unless the incentives align, unless there are pushes for this, it's gonna be like similar picture next SE, a similar picture in future as well. So I fully agree with what Czech government is doing, and I also in a way think like what Amazon did was like having some kind of a cost benefit of actually moving your service to V6, even though I think why they did it was because they're running out of V4. But in any way, the outcome is having some incentive. And to me, that is a bigger story there. So to move forward, I think there needs to be some way the industry needs to start creating incentives because yeah, I understand that there is some limitations with the technology, some limitations with CPE, but all of them can be solved if there are enough incentives. And yeah, we have been over a decade or more than a decade talking about V6. So, and there is some movement, of course. It's not completely lost or nothing is happening, but still, I think unless we align those together, and the demand then rises, then we will actually see more and more adoption over time.
Yeah, thanks for that. I know you and the research team at the RIPE-NCC, as well as the data storytelling team, do a lot of work in looking across the entire service region and comparing numbers, looking into internet penetration numbers and stuff. How do you see Southeast Europe compared to other parts of the service region and the world as well? Is there any lessons learned that you could share based on that?
So yeah, definitely. I think the Southeast Europe is lagging behind. The rest of the Europe is doing well. Netherlands is one good example. Germany another one. And if you look at the numbers, not only from the capable part, but EPNIC has data which they collect from Google Ads that also shows the adoption to some degree. And there you see, for instance, India doing really well. China is also having really good now, like more and more ASNs and more people are supported V6. So I think those guys are doing pretty well. From what I know, that India also has cellular networks that are doing V6. So it does seem like other parts of the world are moving forward in this, and the SEE region needs to, I think, step up the game a bit.
And just about that incentives, because you mentioned like AWS and there being like a price to continue to do IPv4, right? Because and a lot of people that have been talking about doing IPv6 for years have been saying that, you know, there needs to be the right markets to that, like the checks and balances when it comes to pricing needs to act in that favor. What I heard you say a couple times now is you think that these having IPv4 more as a service and it costing more would help with V6?
Yeah, I think that probably is one of the way to tilt it, that make IPv4 so costly that people would start thinking about like a cheaper solution, because at the end of the day, businesses are also there to make profit. And if V6 is more profitable, I think that's gonna change from the perspective of people start thinking about, okay, we need to now actually move because it's gonna save more money. One of the examples we already saw, that it took some time and effort from moving towards V6, but at the end it does save some pain for the engineers to don't have to deal with SIG-NOC and services like that, and then easy troubleshooting. But from the business standpoint, I think unless those kind of things are there, then the management probably would start thinking about the V6. And that's also what we see from the survey, that there are two challenges, right? There was one about V4 and V6, that's understandable. The other is actually the decision makers have to start thinking about V6 only. So that was also pointed in our survey.
No, thanks for that. And looking at you again, Vasja, is there a point where you might be providing like your default services on IPv6 only, and if people want services on V4, then you charge them for that? Do you see that point happening anytime soon?
We thought about that at the beginning, what to do if we move to IPv6 only and do some kind of translation. But the easiest way, having already running a network on IPv4, was to just add the layer of IPv6. And we saw that the traffic just goes naturally to IPv6, so we are just waiting that the decreasing of the IPv4 traffic. Yep. There is no reason to do, maybe to force it to IPv6. It'll just go naturally on.
But as you pointed out, you're currently running basically two networks, like a V4 network and a V6 network on the same devices, dual stacked, right? Yeah. At one point in time, do you see that it might make sense that you just focus on the V6? And if a customer comes and asks for V4, then you charge them for that? Because that was one of the ideas that was floated a long time ago. So
maybe yes, but we have to wait that the trend will be inverted. So that most of the traffic, at least 80%, will be on IPv6, and only 20% will be on IPv4. In that case, maybe translation maybe will have sense.
Okay, thanks for that. And George, similar question. I'd like to hear your thoughts on it, but also in the context of also mobile, because we've seen some doing IPv6 only for mobile. And is that something that, I know there's some challenges, and I'd love for you to explain them, maybe like roaming and such, but I'd love to hear your thoughts on that as well.
Okay, well, as I mentioned, our target is to launch this new service in the 5GSA world, IPv6 only. So we are really struggling to go towards this direction. In general, I would say it's, but why? Because as I mentioned again before, mobile users don't really care how they're going to get the content. But I think Adonis, I don't locate him now, mentioned earlier that in Greece, there are 1.5 operators that are doing V6. So there is one that is doing, I would dare to say that would be us, half, which is one of our competitors, and 0, which is the third of our competitors. Okay, so if we stop providing a dual stack or charge it differently, they would just leave the company and go to our competitor. So it's really not an option. Okay, we are doing what we're doing. A bit romantic, we believe in that, but it's also help us in the way we evolve our network, not our network operations, because you mentioned it perfectly. We have to operate 2 networks in parallel, but eventually, I think it's worth it to do that. Okay.
Yeah, please, Pavle.
I just want to jump in about this pricing because it's regulated market. You have to know this. So to increase the price on some products, it's if you're not only if it's not easy as it looks like, because they have like situation with this switch off of the copper. So you have to switch from the copper to fiber. So to do this, you have, even if you are, let's say, dominant operator, you have to fulfill some first to fulfill the threshold, and then after you can switch the copper network. And then sometimes some people, they don't want to switch from the copper to the fiber for them, no reason. But it's still regulated. It's not like it's so easy to just to increase the price for the same service, but on a different technology, different prices. But especially if you don't operator, you cannot do this. The rest one, you can do this. So it's you have to also to take care about this.
Yeah, no, makes sense. At this point, I'd like to open the mics if people from the audience would like to ask questions and comments. Yes, I see a few. Great, please.
Hello, everyone. My name is Alain. I come from Kiev. I'm working as managing director of Black Sea region in Chariton. I'm not sure that everyone knows, but we as big backbone provider for providers, for the local SP. And you speak about the pricing. Can it speed up or not the adoption IPv6? And I can share with you initiative what our CEO dropped last month. The Chariton is providing free of charge IPv6 any hour on net point. It's around 60 countries now. If alongside IPv4 as a main written IP transit. That's why. Let's see what happens on the Serbia, Bulgaria, Romania next year, because it's my direct responsibility of the driving business. That's why maybe next year in Sofia we can discuss what is going on. It's additional percentage or not. That's why, and yeah, we launched over DVDM last 2 years in this country. That's why terabit is available capability for connectivity. Thank you.
Thanks for sharing, and hopefully, indeed, the SEE meeting in Bulgaria, you could be on stage and you tell us the experiences that you see there.
I have a lot of experience to share, for example, for Ukrainian driving business during the different times. That's why, yeah, thank you. I will be.
Thank you for that. Yeah, please.
Hi, Brian Reiter. I'm actually the chair of the Croatian NOG, and we had our NOG event last Thursday, and we had the exact same panel regarding IPv6, and why we have only roughly 4 to 5% of all IP traffic on IPv6 in Croatia. So we had on the panel like ISPs, regulators, and industry members, and just wanted to share the conclusions there because, yeah, the IPv6 adoption in Croatia is really low, and basically the reason was that, first of all the operators have enough IPv4 address space. They don't see any need to go to IPv6, although their core network is dual stack. They offer IPv6 to business customers, but the final push to push the IPv6 towards the residential customers is missing. So what is needed to make it widely adopted? It doesn't help that the government is purely IPv4, but basically the push to make IPv6 widely accessible is financial. So there is a big issue with CPEs. Not that they don't support IPv6, is that the vendor, first of all, the vendors don't care for the small deployments, and each and every operator has probably like 10 different vendors in production. It's real difficult to make them all support IPv6 in a working way, because each and every has their own issues, and fixing each and every issue takes time, costs money. And for the management of these big ISPs, they don't see the value in providing IPv6 apart from like it's the future, because it costs money, and all these ISPs are nowadays understaffed, and there's always lacking money. So basically there is no push in the creation community regarding IPv6 due to these reasons. And now what we see is that the regulator actually is looking into how to force companies to implement IPv6 for the residential market, because there is currently no other way, since the ISPs are unwilling to provide to the residential customers, purely for financial reasons. Yeah.
Thanks for that. And just to clarify, if I understand you correctly, the ISPs in Croatia do not provide the CPEs, or do they?
They do, but it's always like a mass production, but they buy it in bulk.
Yes.
And the price is the common denominator. The lowest, they give a minimum set of requirements to get the cheapest price on the CPE. And when you have different vendors which have different IPv6 capabilities, and IPv6 is mandatory, but they never test it thoroughly, and there's always different sets of bugs with each and every CPE. So that is basically the main reason why it's not widely adopted.
So it's just the V6 capable logo that they have, but without testing actually the features there.
Yeah, there's some basic features, but the support is really lacking. And like when you build a network, when you have like 100,000 or 200,000 subscribers, like the CP is probably the biggest expense you can have in your network. It's like one piece is not so expensive, but when you have it, a lot of them, it comes like more than your core network. So it's like every euro counts. Yeah. And this is something the operators are saving on, and which they don't have basically time or the money to just go with it to implement IPv6 fully.
Okay.
Yeah.
No, thanks for that. Thanks.
Yeah.
That's a good answer.
Welcome.
And George, you kind of touched on the CPE as well, but you also provide the CPE, according to my understanding, but you've got over that problem.
Yeah, we provide the CPE and we manage the CPE, but we ask for specific implementation to be on the CPE. There is a specific protocol you have to follow if you want to go to IPv6 only. You have to choose something and stick to it, and your CPE vendors have to support it. But it is true what we just heard, and it gets expensive. Okay, definitely. But what else can you do?
Yeah. No, I understand. Any other thoughts, comments from the floor? Yes, please.
Hello, Arun Shunal Zeront. I was wondering, with the implementation of IPv6, in the case of a criminal court case, let's say, and you're supposed to prove to the court that the IP address of the CPE, the customer, is indeed the customer's, so you pinpoint it to the person that is being prosecuted. Does IPv6 make it easier because you can assign public IPv6 addresses directly to the CPEs instead of doing SIG-NOC with IPv4? Thank you.
You kind of touched on that, Pavle.
But I will start a bit.
Yeah, okay. Go ahead, George.
Obviously, if you're hidden behind CGN, you cannot do a lot of things unless you are forced to have a huge investment of logging everything, and also have the support from the other end. For example, Facebook must give you an IP and a port in order to be able to correlate. I don't think that is happening. But practically, it's the only way to become sort of compliant in that environment. It's no other way.
Okay, we have the same problem exactly, and I know the Facebook just give the IP address, so operator then asks for us to give you source port, destination port. Then if you give him like a domain name, it's not enough. You need an IP address, and always going around. And also what George said, they have a huge investment, but then if you see, it's better to force them to make a huge investment to identify unique person behind the NAT, or to maybe to this money give to the IP, to deployment of IP version 6. They have to make a trade-off. I'm sorry to hear this from a colleague from Croatia, because our, let's say, biggest provider, it's so the owner of our bigger provider, it's Croatia Telecom, so it's probably the same politics in Croatia like in Montenegro, so they want to buy this CP, so we are stuck. But maybe this 4IG, which is owner of one mobile operator, maybe they will do something. But usually in Montenegro, if one operator implements something, the rest follow them. So I think if they cannot put something on the billboard, IPv6 is better for this and this, I think they will wait until end to implement it.
So you touched on an interesting thing, and last year we also had research work and a panel on the fact that a lot of companies in the region here are owned by mother companies that might be in the region or might be outside of the region. To get IPv6 deployed, do you think that's something that you discuss on the local country level, or do you need to go to like the mother companies and have them push down that as a strategy?
I mean, probably the mother companies decide about this. Maybe if they want to use like usually they in the past they use like Montenegro like a pilot project, because it's a small country, probably it's a small investment, so they try it, how it's working, and then maybe implement in the, let's say, the country where is the owner is. But in this case, there's no movement. But I think in Germany it's a high up of over 50%. I mean, it's take up of IPv6. Also in Hungary it's like this. In Serbia it's a bit low. It's owner of third operators. So all operators in Montenegro are owned by the company outside of the Montenegro.
Okay. I'll circle back to panelists on discussion, but I see a comment, please.
Hi, Blagoj, Spider Macedonia. I want to ask you, do you aware of some vendor or hardware who is only IPv6 configuration inside? Maybe that will produce more advanced implement of IPv6.
You mean modem that's v6 only?
Yes.
That does not support IPv4?
Yes. Someone is aware about hardware like that?
Mm-hmm. I'm sorry, I have to answer with a question. Who would buy that?
That is a good question, but if some vendors have to offer some kind of equipment, maybe Vasja will buy it because he have only IPv6 addresses.
Yeah,
it's a different way of thinking.
It's an interesting one, and I'm looking at Jan now because I'm going to ask him a question. At the IETF, I remember that a while back there used to be the IPv4 sunset work that was done, and they were looking into when certain network cards boot, they require v4. Where did that work go? What's happening there at the IETF level?
Well,
for those that don't know you.
Sunset.
Who are you?
Oh, who am I?
Who are you?
I'm Jan George. I'm from Slovenia. The thing at the IETF went into the infinite loop that escalated into catch-22, and then it died of a horrible death, sadly. Because people that wanted to push forward the IPv4 sunset, they just gave up. But we didn't mention it yet. There is a very good initiative from the Polish government. They accepted not the law but the resolution that every public service that is on the internet has to implement IPv6 until 2028, I think, something like this.
You mean the Czech government?
Czech government, sorry,
yes.
Czech government.
Yeah.
And with the yearly reports, and on the 6th of June 2032, they will switch off IPv4 for all public services that are provided to the normal people. So this might be a good incentive for the operators in the country to actually implement IPv6 and offer it to the end users.
No, but thanks for that. But just kind of circling back to that V4 sunset thing, and correct me if I'm wrong, because I remember to the question that was asked, are there modems that are just going to be V6 only? My understanding is that they need to boot on V4 first before they can do V6. Do you remember that work?
I don't think they had to, but now I think this should be fixed. It's like 2024. I think that lots of operators are now pushing the CPE vendors to actually implement the part of 464 XLAT into the CPE to follow the path of the mobile operators when the CLAT is actually part of a CPE, when you can have the private IPv4 addressing behind the CPE and IPv6 only from the CPE to the core and then to the translation, where you can reach the legacy part of the internet.
Yep. No, I appreciate the answer.
Can I go back?
Yes.
Thank you.
And thank you for speaking. I know that you have difficulty speaking, so thanks for that, Jan. Yep, please.
Branimir again. So I just want to reflect a bit what Pavle said regarding the different countries which are owned by bigger companies. There's a difference between, for example, I will not name a big provider in Croatia, which is also an owner of ISP in Montenegro. The German owner basically has a much more expensive CP in Germany rather than in Croatia and Montenegro, and this is actually a big part of the equation. So countries can implement IPv6 on their own, but they lack the financial means to do it. And reflecting also to the question which Blago had regarding the IPv6 only equipment. So I was fortunate enough to work on a project in 2013 on an IPv6 only network, and I was connected at my home for 4 or 5 years for the duration of the pilot on IPv6 only. So it works. I mean, it's not something that's for testing. It works, but the project was closed due to financial reasons. So if you have the money, it works, but if you don't have it, it's not really high on the priority list.
Yeah, no, thanks for that.
Thank you.
Vesna?
Sorry, one more comment.
Oh, please.
In the IPv6 only, I thought of an example. Sorry, I cannot consider, have eye contact, sorry. iPhone could be such an example. If you're working in an IPv6 only operator, the operator will push the configuration, and the settings aren't configurable from the end user. So it's a device that, of course, has capabilities to work V4 only, dual stack, or V6 only. But if the operator push the V6 only setup, then it's an IPv6 only terminal. And it's quite popular, I could say. Okay.
And I wanted to answer to that also.
Who are you?
Because my name is Vesna, I'm from the RIPE NCC, and I'm speaking for Tore Andersson, who has been working a lot on promoting the IPv6 only protocol stack and the data center. So he presented at some of the RIPE NCC events about it, and he wrote RFCs about it, and a blog post at LACNIC blog. That's like the recent one, the most recent one. He designed the IPv6 only data center with the financial savings in mind, and so it does work. It has been made to work, but maybe again going back to Branimir, if you are from Norway and you have money, so that can be a consideration too.
Yeah, please.
I'm Božo Krstajić from University of Montenegro. I'd like to share some experience from Montenegro in some a similar initiative in past many years. For instance, for distance learning, for e-learning, for some other initiative which I pushed with my team many years ago in Montenegro. Each time it's happened that we have to be prepared and ready to implement that. And something happened after that, and deployment do like just that. For instance, distance learning, we pushed maybe 20 years ago and promoted that and tried to establish in many faculties, but nothing happened. Almost couple faculties use that, but when happened COVID infection, for 20 days, 1 month, all institutions implement instance learning or distance learning. So that means we have to be capable, we have to have some trainings to be ready, and maybe some or government body or something like that. We have some occur something, some events, and we will deploy that, especially in Montenegro. That's my opinion.
Yeah, thanks for that, Pedro. I appreciate it. And I appreciate that we're hearing from a lot of different countries. We're getting, Montenegro, we heard from Croatia, we have Greece, well, Slovenia. So yes, other countries, please, that are in the room here, feel free to share your experiences, not looking at anybody particular. But looking at my panelists again, while people are thinking if they want to go to the mic, pain points. Like, what's been your biggest pain point? And if people can think about that while we go around, like, the biggest hurdle that you are still, like, you had to go over or you're still going through with IPv6, what would that be?
Maybe still the CPs that will be ready till the end of the year. So we're trying to solve mainly this problem because we are pushing IPv6 through the radius out, but it's not on the other end. It's disabled, so that is it.
And in terms of technologies that you're using, you find interoperability technologies that there's no feature parity, let's say, between what you can offer on v4 and v6 today?
There is a performance increase because the PET it's shorter, so but there is a performance increase, and it's straightforward connection. So we don't do anything. So we even do not track that connection.
Okay. Yeah, thanks for that. Pavle?
As I think right now, I think that when we do this, it was like in a strategy, and then we thought, okay, we make the plan and it go everything by the plan. But I think we should have included the government at the moment and talk to operator, made a meeting with the operator in the government, and maybe make some decision, set the date, because like this, I think it's always it's easy to find a reason not to do it, I think, like anything else.
Thanks for that. George?
Well, I wouldn't point something technical. I would say the biggest problem is cultural. Okay. All technologies have problems, and all are solved one way or another at certain time. But you have to want this. You have to follow the change, or to be willing to spend some more time. And IPv6 is a driven, let's call it technology, from ISPs and from CDNs, but it's not from the networking industry. Okay, that's the biggest problem that we have, I would say.
I think that's an interesting point. I'll stay with that for a second, because like if you look at the law of diffusion and adoption of technologies, you have like the different phases where you have like the innovators, the first movers, the laggards, and there's like a science to this. And what they usually say is like there's this conversion point around like 18% once a technology or an idea gets diffused, it gets mass market acceptance and adoption. when it hits like that 18–20%. In Greece here, you have higher numbers, but you still struggle with what you're saying.
Yes, because these numbers are practically the end users. That the third time I'm going to say that. They don't care. They just want the content. But people who design networks, who build solutions, and who have enterprise to support their end users in an enterprise environment, they just want to be able to solve their problems quicker and easier. And when you have 2 stacks to support, in whatever terminal you might think of, it's a bit more difficult. It's maybe double difficult.
It's double the work. You're provisioning over 2 networks.
So again, it's cost.
Mm-hmm.
You want to, yeah, it's difficult.
Okay, that's fair. Qasim?
Yeah, I think it's right that it's also a lot of cultural that comes into this, that people want to actually adopt. Have to put energy, time, and resources to get V6. I think one of the studies that I saw from Washington University was to look at different industry types and see adoption rates across different industry types. And they, from their data, they were able to say that the cellular are the faster growing, but as George said, like the enterprise network are the slowest. And they, with their research, they pinpointed that the enterprise networks are actually where the customers are, and they probably do not either have enough information or they don't want to move because it just works, and this is more simpler for them to actually move. So again, my initial point of incentives, that needs to have the right incentives for them to actually start moving, and they are like the ones that are making this whole thing lagging behind.
Thanks for that. Looking at the room for final comments, I see we couldn't keep Jan away. Jan?
Jan. Well, maybe we should all go back home tomorrow and talk to our governments and make them follow the example from the Czech government. It's 6th of June 2032, and that might be the IPv4 sunset day.
Actually, that's an interesting thought, because for the original IPv6 day, a bunch of big content providers, the Googles, the Yahoos, the whatever, they agreed on that day, all of them, to switch it on together to address the brokenness. And maybe if a number of governments take that jump together, that might be that next step, right?
And I have a feeling that the RIPE NCC with the policy team can also help in this matter.
The RIPE NCC is always happy to provide any support that we can, obviously. Other thoughts, comments from the ground, the floor? No? If so, thank you very much. This has been a great panel. Thank you to my panelists. Please thank them with me. And we now have a coffee break, so please enjoy.
Hello, everybody. Let's start the next session. I hope that they rang the bell so people will come in. Please find a seat. If you have a question, go to the microphone at the end of the presentation and state your name and affiliation. So, Eric, who's first?
So first presentation, it will be from RIPE NCC with Hisham Ibrahim. Will present an RIPE NCC update. The floor is yours.
Hello once again, everyone. I am Hisham Ibrahim. This time they remembered to put a slide with my name on it so that I actually say it. My name is Hisham Ibrahim. I'm with the RIPE NCC. I was the guy in the IPv6 t-shirt for the IPv6 panel, but now that I'm giving the NCC update, I am in a suit. And without further ado, talking about the RIPE NCC, our mission here, I will not read it out, but as you can see, the mission here is of 3 parts. The first one is we are the authority on the unique internet numbers, as in the registry, as a lot of you know us to be. We register IPv4, IPv6, and AS numbers, internet number resources for operators to be able to build and operate the internet. We are also the secretariat to the RIPE community. That means all of you. And you've heard Miriam yesterday talking about the RIPE community, inviting people to the RIPE meeting. We were created as a secretariat function to support the work that happens there, the working groups, and all the work that's happening in the community, from policy development work to NWI's new work items that are developed in working groups. And if you are interested in more, please find me and I can tell you more about what's happening at the RIPE community and the RIPE meetings. We are also a neutral source for information and knowledge. So we provide information services that are needed for the internet to operate, be it K-root, for example, one of the root servers, but also the internet measurement services that we provide and the insights that we are able to process through services like CRIS and others like Atlas that have proven time and time again useful for network operators and for the developments in different regions. And you heard the presentation from my colleague Qasim earlier. That was only possible due to the fact that we do have these data services. Now, I won't go into all the details of what we're seeing here, but from those 3 elements that are our mission, we do a lot of different activities. Obviously, the research, the registry, the RPKI elements of it, the different measurement tools and DNS support that I mentioned. But also, we do a lot of services in terms of RIPE labs that we can provide those insights and what we see from the internet. Again, Qasim being an example of that. And we are seeing these things not just being useful for the technical community that we engage with, but also we're seeing governments picking this up. So if you were in the IPv6 panel earlier, you would have heard about the Czech government declaring that they want to do IPv6 on their networks. Well, they actually are quoting some of the work that the RIPE NCC has done through RIPE Labs and the country reports to talk about the state of the internet in their country, which is a great collaboration between government and technical community in getting things done. We also offer training and certification, the secretariat work, obviously, and the PDP, like I said. Now, this is an interesting slide that we developed earlier this year at one of the roundtables that we do. So we organize a number of roundtables. We actually had a roundtable alongside this meeting with regulators in Southeast Europe. But earlier this year, we had one in Brussels with EU countries. And in today's internet, for a lot of different reasons, geopolitics, cybersecurity, and a lot of different things, there's a lot of scrutiny on what is happening on the internet for a lot of reasons, like I said. And we looked into who we as RIPE NCC are accountable to. And we're obviously accountable to the RIPE community because we are the secretariat to the community, as I mentioned. So we need to be able to facilitate the discussion and implement the policies and the NWIs, as I mentioned, the new work items that they come up with. We're also accountable to our membership because we are a membership-based organization based out of the Netherlands. So there are certain rules that govern what we can and cannot do. And this ties back to our articles of association and such. We're also accountable in front of government. So obviously the Dutch government that we are established under, we also have another office in Dubai, so we have to follow the laws there. So there cannot be a policy, for example, that tells us to break the law. We cannot implement that. But we also are accountable for EU law, for example, or EU legislation. So when the EU started issuing sanctions on our membership, we had to comply with that. And we actually did. We froze the resources, and there's a lot of work in that. If you're interested in knowing what we did, please chat with me afterwards. But we also need to understand the implication of national legislation on our members as well. So if there is a legislation in a country that affects our members, we need to understand how that plays into them being members of us. And there are examples from Russia that I could mention if anybody is interested. And last but not least, we are accountable to the global internet governance system and internet operations. Like I said, we operate a registry, we operate root servers, and there is certain expectations of us being able to deliver on the work that we do there. So being able to satisfy all this, and especially in a time where there's increased scrutiny and different objectives, is where we find ourselves now as RIPE NCC, trying to navigate all this. Now, talking about one of the topics that are quite heavily discussed now, so the charging scheme for 2025 and 2026. So the charging scheme, we propose models that guarantee that we have the funding that we need for 2025 and 2026. The board put them forward to the membership, and there's currently discussions on the mailing lists about this. So the launch of the consultation was done in March. A lot of people have a lot of opinions. It all boils down to everybody else should be paying more than me, right? Because reasons. And please make sure that if you are a RIPE NCC member, that you exercise your vote and that you register and vote at the GM and have your say on the charging scheme, but also other stuff that's being voted on, including board elections, which I think, yeah, is coming up in the next slide. So the general meeting. So we organize at the RIPE meetings a general meeting for our members. We do twice a year. So the one coming up is the one in May, and it will take place on the 22nd to the 24th of May. It's online and adjacent to the RIPE meeting in Poland. You've seen all the advertisements for the meeting so far for RIPE 88. So even if you cannot participate in person, you can still participate online and register and vote online, and please make sure to do so. There are 3 resolutions to vote on from the executive board that tie back to the charging scheme discussions that I just mentioned in a second, but we also have the board elections. We have 2 seats open for election, and we do have some candidates that have applied to the board that are here in the meeting, so please make sure to have a chat with them if you have not already. Register for the GM, and here's a link for this. The slides will be online, so you can easily get them done. And if you need more information, here's a link for that as well. Just to show some stats, because if anybody knows me, I really like numbers and data and stuff, so we make a point of showcasing them. So just showing participation numbers from the Southeast European region. So the percentages per country is what you see in the bars there. So the total number is between brackets. So for example, Romania, out of 168 members that we have, more than 50% of them actually participated and voted at GM. We like to see those numbers going up because, like I said, these tie back to how we as a membership association govern ourselves, fund ourselves, and also we consult our members on our activity plan and budget when that is produced. This is not this round, it's the next round. Now, there has been a lot of discussion, like I said, around the charging scheme, including the sustainable future for funding the RIPE NCC moving forward. We're coming out of a few years where things were easy and good. We had a lot of members coming in, signing up, a lot of LIRs signing up to get additional resources, which meant we had a lot of money. And when you have a lot of money, everything is easy and everybody accepts everything that happens. In fact, for the past few years, we have been redistributing the excess funds that we had because as a non-profit organization, we're not doing this for any kind of profit. So at the end of the year, if we have collected more money than what we had planned to spend or that we have actually spent, then we end up redistributing that again. Now, moving forward with IPv4, the state of IPv4, and we're seeing a lot more consolidation and less LIRs opening and coming in. There's a lot of these discussions now about the future funding model for the RIPE NCC. And for that, one of the board members, Remco, who is also here at the meeting, put out a very interesting article. And he is inviting members to discuss this, whether at this event, but also at the RIPE meeting as well, where I believe he reached out to the PC for a buff session to be able to discuss more. And I am hearing now that that buff session was approved. So we have that, but that will not be the only part of engagement. So please engage there, but it will not stop at 88. This is part of a bigger plan to seeing how the NCC could continue to offer to play the different roles that is in its mission, while continuing to offer the services that people have grown to rely on, and fund the model in a way that makes sense for its membership. So this is a really interesting and important discussion. Please make a point of being part of that. Now, I asked Carla, who helped develop the site, who actually developed the slide, so I appreciate that, Carla, to add in a slide here after the question that we got yesterday from the gentleman from Kosovo. I see you in the back of the room. Just to clarify maybe for the rest of the room here what the topic was and the issue that was being discussed. And it mainly goes back to the use of country codes in the RIPE database. So for those of you that may not know, so when a member applies to become a member of the RIPE NCC, an organization, a network applies to be a member of the RIPE NCC to get their resources, we ask them for establishment papers. And they need to issue them from the government that they are established in. Now, in the database, we register the country code of the country that they issued those papers from. And that's the only reference to them. So the fact that there are resources registered under a country code doesn't mean necessarily that those resources are used in that country. So to just give a random example, Deutsche Telekom, if they get resources, you'll find them registered under DE. However, Deutsche Telekom has a lot of branches all over the region here, and they might be using them where they want. However, if you look them up, because they're registered under DE, you would find them under DE. So the specific case here was about Kosovo, because the way that we do this is the RIPE NCC assigns these country codes based on a standard, the ISO standard 3166. The reason why we do this is A, we need to be following a standard, because we as an organization, we're not in a position to determine what is a country or not. That is not our role. So we're following an international standard, and this is the international standard that has been widely adopted, not just by the RIRs, but also by the CCTLD world. So for example, .gr, the GR in that name is from this standard. Romania, RRO, Serbia, RS, and so on and so forth. Now, in that list, Kosovo does not have an official country code assigned to it. Kosovo has been using XK, which is one of the user-defined ones. And if anybody has been following discussions about IPv4, you know that there were IP addresses that were put away for future use that nobody can use because other people took them and built them into other bits. So just using XK today might break other stuff for other people. This is why it needs to have an official entry there that everybody recognizes for us to be able to provide them that. Now, this issue was flagged to us at least 2 years ago, and we have been looking into getting all the information, looking into all the different options, and was discussed at the board level a number of times. We took this very seriously, because it's not just Kosovo in this case that we've seen. We've seen other cases in our service region as well that have similar issues, and not just in our service region, beyond that as well. I can give examples, but the point here being we need to follow a standard. So what we found, and there is a board, sorry, there are board minutes that are in the slide here, where at the last, at the board meeting number 172, this was discussed and determined that, yes, indeed, ISO 3166 is the best standard that we could find that can cater for all the corner cases that we are finding, so we continue to support that. However, what we are doing is trying to work with the community to see how they can follow the process to get that fixed. So there are no shortcuts here, it just has to be done through that process. And there is a RIPE Labs that describes all this in details that my colleague Kirsten wrote last year. Now, what we have been working on, and again, the way Carla thought about these slides is I start with the heavy stuff and then I end with the light stuff. So now this is the lighter stuff. Sorry. Since then, we've enforced two-factor authentication for all the networks that we have and access controls that we have so that people would not be subjected to something like this in the future. And my colleague Felipe wrote a really good article about the work that we're doing. Thank you, Diane. He has a sore throat too, so he feels my pain. Yes, like I was saying, my colleague Felipe wrote a really good article about the work that we've been doing there. We also received a lot of feature requests from the community, and he does talk about future enhancements that we're planning on doing there in the technology. We really do listen to our community, and we try to do what we can. Another thing is the data measurements tools that we do. So all the stuff that is related to RIS, related to Atlas, related to all the stuff that is really relevant to and valuable to people that are looking into either the history of the internet, how the internet reacts with certain changes, or providing insights like the data-driven storytelling elements that you saw in Qasim's presentation and the article that was published by our data storytelling team. These provide really great insights into the internet, and like I said, we've seen them heavily used and appreciated by governments, technical community, and others as well. It's very easy when you see the internet visualized in front of you from at least the vantage point that we see. And it becomes a lot more interesting when you talk to people with different vantage points, because as one of my colleagues says, this like beautiful mess that is BGP, trying to understand how that works. And again, we saw some of that in the presentations today. It really is interesting for techies like myself and like most of the RIPE community to talk about this stuff and see how the internet reacts under different stimuli. And we're always fascinated by how resilient it is. I love RIPE Labs. I cannot say that enough. People that have heard me talk before, they've heard me say I really love RIPE Labs. It is a wealth of information. We publish a lot of articles there, actually most of them written by the community, about interesting things that they're seeing online and topical information that is great. Now, I believe since last year we added the podcast, or from the year before? Last year? The year before. The year before. So for 2 years we've been doing podcasts. Those are even great. Like, I'm not a podcast person, but I listen to all the podcasts that we do there. And Anastasia in the room here, she does a lot of work in this area here. I believe some of you might know that we had the ERNI meetings, the ERN folk that had a meeting right before the SEE meeting. She also did some interviews with them there, and hopefully you can hear some really fascinating stories about how the internet works. Also, Qasim had one of the podcasts recently released. It's really interesting and fun, a nice way of you to get a stream of information while you're walking, cycling, doing whatever you need to do. I'm really happy with the work that's happening there, if you cannot tell already. Community project funds. Again, something that we do as Secretariat for the community. So the way that this works is there is a committee from the community that evaluates the different projects, and they are awarded a total up to 250K a year based on what they put forward. My colleague Alistair, he's not in the room. Oh, he is in the back of the room over there. He looks like an ex-cop. Talk to him if you want. He will provide you with a lot of information. We have been supporting a lot of great efforts and projects over the years, and we want to continue to do more. There have been recently also some discussions about previous projects and funding and stuff. Al has promised that he will provide more information leading to the RIPE meeting for anybody that wants more information there. But if you have an idea, if you have something that is interesting, please get in touch with him, learn how to fill in the application. And like I said, we have a lot of really great success stories that have been funded by this, some of them even in the room here. RIPE NCC Academy, also a great source of knowledge and information, and our members tell us so. This was something that we started even before COVID, but really paid off during COVID years. And is paying off also in our being more green and sustainable efforts. Instead of jetting trainers all over the world trying to get people trained, what we do here is we provide these excellent, and this isn't my word, this is the MPS scoring that we get, courses on topics like IPv6 security, BGP security, the RIPE database, and other topics including internet governance and micro-learnings on ping, traceroute, and such. It's a really valuable resource. I believe we get per quarter around 5,000 plus modules completed. So there is a lot of interest there. And one of the things that we actually did also is the certification project program, because we saw a lot of people that wanted to demonstrate that they learned something and get a certification for it. So you can also get certification on almost all of the courses that you see here listed. And if you have not talked to them already, my colleagues from Learning and Development actually are in the room now. They have a booth outside. They've been collecting learning needs from anybody that is willing to talk to them. They've been gathering a lot of good information to fix and make things better for you. So if you do have thoughts or learning needs, make a point of talking to. Can you raise your hands, please? Yes, those two over there. Thank you. Yes, also this is something that we launched last year that I think is really cool, and I'm happy that we're continuing to do this. So the RIPE meetings predominantly happen in Europe, and we understand that that puts a financial barrier, a visa barrier to other countries that might not be able to travel to Europe to attend a RIPE meeting in person. Now, for years, RIPE meetings have been organized so that they are online. You can stream them, you can follow the activities. During COVID time, we also learned a lot of lessons on how to do hybrid meetings and keep them online. So this was now, the technology was made easy for us to go the next step and go local hubs. Instead of you just following the stream in your own house, why not host a local hub in your country that allows people to come together and meet their local community, have a bit of a chat, have a discussion about what they're seeing in the sessions, and be able to follow online what's happening at the RIPE meeting. Vesna, who is not in the room now, she is back there. She did an amazing job last year where we got 6 local hubs from all over our service region. And we're really looking to beat that number this year. So please, if you are interested, it only costs you a location that has good internet. And you advertise that to your local community, and then you're a local champion, right? That's organizing this stuff. It would be really appreciated if we can get more of these this year and 2 years to come. This also fits beautifully with the less travel, more sustainable approach that we're trying to get, but still involving more people and integrating them into the RIPE meeting, which we want to see, and removing all the barriers, because that's a key thing that we have, right? And with that, RIPE 88 happening in Poland. I'm sure by now you've heard that, 20th to the 24th of May. Here is the photo and the postcard for that. And I believe before Jan finds the minute thing, I am done.
I knew you were done. I just wanted to use this.
You were chairing, I get that. Yes, Dimitro, please.
Oh, Dimitro.
Sure. Yeah, I can spend another hour criticizing or praising your presentation. In fact, I like it. Yeah. But I just ask you about the little Kosovo thing.
Yes.
You know, I saw at least 3 ways that people from Kosovo do with lack of the code. Mm-hmm. You know, they use EU, which is European Union. And so your statement that ISO is standard for the countries is only particularly correct. As a TLD manager for Ukraine, I know that not every 2-letter code is a country. Like the SU domain still exists, even though Soviet Union collapsed in 1992. And so did Yugoslavia, and so many. And also saw them using the Albanian code. Mm-hmm. So the question is, what does RIPE NCC do when Albanian LAR applies? Sorry, Kosovo LAR applies. You put them in Albanians, you put them in EU, XA.
I think that's a good question, and it actually is answered in that RIPE Labs article that I put here. So basically, we offer the member the choice to register under country code that they choose. Most of them choose Albania.
it only applies to the people from countries that are not on the list.
Yes.
So when the RIPE made Ukrainian LARs from occupied territory to choose Russia, that was a different policy.
No, that is a different story. So in the Ukrainian case, what ends up happening is, like I said, if a company provides us with papers, we document where those papers were issued. So if a Ukrainian company provides us with Ukrainian papers, we register them under UA. If a Ukrainian company provides us with Russian papers that link to their initial Ukrainian establishment, we register them under RU, which is the papers that we are providing.
So it is a position RIPE and CC to accept occupied territory of Ukraine to be registered as Russia, as long as the company says they're Russian company. Yes or no?
We document...
It's a self-selection, not your selection.
No. So in this case, we document where the documents were issued.
You know that the company cannot change the registration to another country.
I understand. Right? So like I said, the Russian documents that we get actually have a link to the original Ukrainian registration numbers.
I would not contradict that. Thank you for explanation, though.
No, absolutely.
Thank you. Is there any other question? Now we have Hisham here. He needs to respond. Okay, no questions. Eric, who's next?
Yeah, thank you very much.
Thank you, Hisham. Next, we have Jelena Kosic from RPKI with a nice presentations about your proposal for fundamentally new telecom market. Jelena, floor is yours.
Thank you very much. So, hi everybody. My name is Jelena, and I work as a community builder for the RIPE-NCC for the past about 2 years. I am from Serbia, but I have moved to Amsterdam recently for the job. And we're going to switch the lanes a bit, and we're going to talk about the regulatory developments. I'm going to give you the update on the most recent EU proposals and recommendations that are related to the telecom sector. Okay, let me just switch up the slides. Green. Yeah. Okay. So specifically, we're going to talk about the connectivity package and the Digital Network Act. So if we were to summarize the whole debate about the future of connectivity in Europe, we could perhaps use these set of statements here that I hope you can read. Essentially, the part of the telecom sector is claiming that in order for the EU to achieve its connectivity goals, the additional funding is necessary to close the so-called investment gap. And on top of that, parts of the telecom sector is also saying that they're calling for or advocating for the deregulation of the sector and introduction of the new telecom regulatory framework. And here I would like to remind you that the current regulatory framework that we have in place, I mean European Union, has been adopted quite recently. It happened just before the COVID hit, and the implementation stage was quite long and slow. So few member countries have just recently introduced this regulation into their national legislation. And the last point is the interesting one, where again, parts of the telecom industry are claiming that there is too much competition in the industry, and this is something that they relate again for the need of investment by saying that, well, considering that telecoms are natural monopolies, too much competition can hurt the potential investments, and it is possible to have too much of a good thing. So we can discuss all of these points throughout my presentation and later with your questions. So I mentioned the connectivity goals. So this is what I meant. Back in 2016, European Commission adopted its strategy on connectivity for the European Gigabit Society. Then in 2021, they presented, so the connectivity goals were part of the broader strategy called Digital Decade Targets, and very simply put, that means that the goal is for Europe to be the most connected continent by 2030. And to be more specific, what we mean by that, the goal again is to connect all of the European households with a gigabit network. We're talking about fiber optic and 5G networks. So I'm not going to spend too much time. There's a lot of text, but I'm not going to stay here for long. I just want to say that once they introduced this strategy, they also set up certain process to follow and to do some checks. That means that they're going to publish annual reports and roadmaps as a mechanism to see if we're moving in the right direction. You can see the names of these reports, so you can find them online if you care to read more details. But here's what happened. So this is just an overview of different targets that they've set, and the connectivity is just one part of it. But this is the general overview. Okay. And the first annual report was published just last year, and it showed that even though there is quite some progress being made, there's still some space left to reach the full goal that we're set. So the report says when it comes to 5G, 81% of the EU population has access to 5G. On the other hand, if we're talking about fiber in rural areas, that's where we're lagging behind, and we're talking about 51% of population having this access. So again, the message here, after the first report was published, is we need to do more, we need to accelerate this development. So this is where the investment gap comes in. And as I said, parts of the telecom industry have identified investment gap of about 174 billion euros. And in order to close this gap, some solutions have been proposed by certain market players. So you see on the slides this division when it comes to this very divisive topic. Some of the proposed solutions can be tied back to the statements that I mentioned at the very beginning. So if we say there is too much competition, the solution could be more consolidation, in-country consolidation, cross-border consolidation. If we say there is an investment gap, the solution could be state aid. Government needs to step up. Other players participating in the market need to step up. This or if we assume things to be true and facts. But at the same time, not everybody agrees with these statements and the proposed solutions to fix these challenges. And there have been some opposing views. Again, I listed the interested in relevant parties. So this is part of the some of the activities, regulatory activity coming from the European Commission. The connectivity package, this is like a regulatory package that the European Commission has introduced in the recent years. It has been published in the previous years. It has three parts. The first part is European proposal, it's an act, Gigabit Infrastructure Act. The second part is the Gigabit recommendations. And the last one is the public consultations that I'm pretty sure that many people here in the room took part of, or at least were aware that were happening last year. So very quickly about the Gigabit Infrastructure Act. It was adopted just 2 months ago, and the most, I would say the key objective was to harmonize administrative procedures when it comes to development of high-speed, high-capacity networks in the European Union. And after this proposal was initiated by European Commission, it was adopted by the European Parliament, and the Commission has welcomed the final version of this act. On the other hand, not everybody was happy. There was a lot of heated discussion, a lot of back and forth. So consensus has been reached, but some parties have been less satisfied than others. There have been some concerns, but the parties who were not as satisfied basically wanted more regulation. They proposed more, certain procedures to be introduced that would lead to more deregulation. This didn't happen to the extent that they proposed. I'm going to skip the gigabit recommendations. It is an important part, but I'm skipping it for the sake of time. And I'm just reminding you about the questionnaire or the public consultation that happened last year. We had an update on this during the RIPE meetings. It is a question relevant to the community. So the main thing that hijacked the whole connectivity discussion last year, if you remember, was the fair share debate. And this was a big part of this consultation. Community took it, like industry and the community, took the chance to share their feedback to the Commission, what they think about these proposals, including fair share. And European Commission took the feedback, and just as we thought that this debate could be put to rest, that's not what happened. And that's why we need to talk about the Digital Networks Act. Digital Networks Act is just one of the planned proposals. And we are just, at the moment, Commission is laying foundation for this type of regulation to be introduced on the EU level. And the first step was the announcement of or publication of the white paper on the future of connectivity. And this white paper was presented by 2 commissioners of internal market and competition at the same time, so jointly. There are 3 pillars. The white paper is structured in a way that it has 3 pillars. Those are investment, regulatory framework, and security one. And at the same time, it has 12 possible scenarios. These are the solutions that European Commission is proposing, suggesting, recommending to the community. But the main intention of the white paper was just to spark a discussion, a dialogue within the industry. And then on the bottom, I summarized in 1 sentence, the best that I could, the nature or intent of this white paper. And I put in bold some of the key words, key phrases that kept being mentioned again and again throughout the white paper. The white paper has 40 pages. It's very extensive. It covers a lot. Maybe it's too ambitious. That's one of the concerns that people were having with it. But we're again talking about, so the white paper does mention this so-called investment gap that needs to be closed and that the market is too fragmented. So that means they are proposing the consolidation to happen. And again, another key word is, ensuring the level playing field. And the level playing field phrase is something that keeps coming up and up and up in this paper for a good reason. And I will try to explain why. So this is kind of the main concern of the paper. It says that, you know how we have traditional telecoms And next to them, we have these new players, the cloud or content providers. And one of the concerns of the current European Commission is that the line between how these companies are operating is starting to get blurred because the traditional telecoms are extending their operations into the fields that traditionally they were not in, and at the same time, content providers are investing in infrastructure and it is getting blurred. So their suggestion was to make, if we're having strict rules for the traditional telecoms, we probably want to have the same rules for all other players. If they're operating on the same level, they should be following the same rules. That's the basic principle and basic narrative that we see in this white paper. And I mentioned there are 3 pillars, and out of them, the second one is the most interesting, the regulatory framework, because it does have a number of maybe more practical recommendations that we can discuss. Out of all of them, on the last line, I kind of highlighted 2 that I'm going to discuss now. So the first one says, well, as I mentioned, we need to have the same rules for all players that are participating in the same industry. So what they want to do is to expand the current regulatory framework so that it includes the content providers. On the other hand, one of the proposals that had drawn a lot of attention of the industry was this arbitration mechanism that was suggested by the Commission for when it comes to peering disputes. So I'll try to explain in simple words so that everybody understands what we're talking about here. So in the current regulation, the European Communication Code, there is a mechanism for taking care of these disputes between 2 operators, telecom operators. The body that is going to be the neutral arbiter is going to be National Regulatory Authority. That's fine. This is what we currently have. But what is being proposed is that in case that there is a dispute, peering dispute between the telecom and the content provider, we're again going to have some kind of mechanism so that there is again a body that is going to make it possible to have financial agreements. So in a way, what is being raised as a concern is that this is again introducing the fair share or the internet tax, but in a less explicit way. It just gives a platform in a way and a mechanism to have the same result, but just choosing a different path how to get to that point. Among other things that are part of the white paper, I also highlighted the regulation. It needs to be adapted to this future where everybody is going to have high-speed fiber optic connection. We don't have it right now, and the regulation is reflecting that. But once we get to that point, regulation also needs to adapt. They also are pushing for or sharing recommendations for the harmonized approach when it comes to spectrum, so that for the operators it's much easier to operate across the European Union. So first reactions to the white paper. It was a very divisive paper. On the one hand, certain associations of first telecom operators and mobile operators welcomed the white paper. On the other hand, other associations of multimedia and digital platforms raised their own concerns. Again, raising the issue of the potential abuse of this peering dispute mechanism being seen as, again, this trick, hidden mechanism to introduce fair share again as a possibility. And what I wanted to share with you is that the public consultation on the white paper is currently open. It's still open to the public. And if you care and if you have opinions, we encourage you to submit your feedback to the Commission. The deadline is end of June, so there's plenty of time, and you can also see the submissions of other people and other organizations just to get the sense of how the community is feeling about these issues. And I would like to summarize everything that I said. So all of these connectivity goals are quite ambitious. Europe being the most connected continent and everybody having access to fiber and 5G. And that's why we have seen a lot of regulatory activity in the past 5 years. But the central themes that I kind of recognize across all of these different proposals is the direction of deregulation, further deregulation of the sector, and harmonization of the rules, procedures across the member states. Okay. Important part, important mission, I feel, of the current Commission is this push to have a digital single market in Europe. And this includes this encouragement for cross-border consolidation. So that if I am a customer of Vodafone in one country, if I move to another country that also has Vodafone as their operator, I kind of can have the service based on the same contract and same requirements. So I can have the same quality of service, basically. But what is happening? This is something that the European Commission is pushing for, the consolidation cross-border, but we are not sure what is actually preventing the operators at the moment from doing so. Is it the lack of investment? Is it the lack of business case? What is actually the problem here that the European Commission is trying to solve? What we are seeing is that, I've seen in different places that the telecom operators are much more interested when it comes to consolidation. They're much more interested in country consolidation. This is what is their priority at the moment. This is where, well, they make some profit. But again, this cross-country consolidation is being pushed by the Commission as this solution to fix everything and to provide resources for the development of the European networks and connectivity. So in short, the Digital Networks Act does introduce some of the old debates, does provide some of the useful recommendations, and but has the potential of leading to another set of long debates that resurface every maybe a decade or so. Again, similar to the previous attempts to solve the problem, even in this white paper, we see that the fair share debate has again hijacked the whole debate. Even though the problem that we're trying to solve is much broader, the fair share debate is kind of the hot topic that is going to monopolize all of the attention. And lastly, DNA, or this proposed act, the future of it, the destiny, is unclear because the current Commission is on its way out. We're going to have the next elections for the European Parliament in June of this year. And this introduction of this white paper and the proposed Digital Networks Act is basically a way of the current commission to put some pressure on the next commissioners that come afterwards into, well, twisting their hands in a way to make this happen. Or not sure if they can actually do that, because I would say this is just a wish list, and they can just be hopeful that this is something that is going to continue to be developed in the same direction. But it doesn't have to happen. It really depends who you select for the European Parliament and who ends up getting the power of control of the internal market and the competition directorates. So I'm open to questions. If anything was unclear, I'm happy to spend time to clarify.
Are there any questions? Thank you, Elena.
Thank you.
No.
Oh, we have questions.
Question. Go back.
Hello. Daniele Arena, Namex, but actually privately. I didn't understand much the peering dispute thing. But what happens, especially
if they cannot agree, okay.
Sorry, especially what happens if the peering disputes happen with at least one of the members who is not a company of an EU company.
Oh, I'm not sure, because this is just a set of proposals. It doesn't go into many details, but so we can just speculate, and we can only understand the nature or the intention of the Commission. But it seems that if there is a dispute between if there is like one telecom operator, where I'm assuming we're talking about EU registered, and then another operator that is like cloud provider, and if they cannot agree, there might be this mechanism that content provider can be forced to pay to use the services, well, the infrastructure.
Okay, why one way and not the other then? Why is the cloud provider paying and not the telecom operator?
I guess,
just, you know.
I guess because the assumption, this is how I read the situation, assumption is that the telecom is going to be asking for something, and then the content provider is going to be pushing back against this the details of the financial agreement, that we're going to have paying party, and that's what I understand. But again, details are very blurred. Like even to me, it's not quite clear. But people are saying this is not what we want at all, and that when it comes to the peering, the whole environment, it works fine just the way it is right now. Let's not touch it. Interconnection works fine. So there's no need to regulate something that hasn't been regulated, and in this way at least.
Is this your opinion or the paper?
That there's no need to regulate further. This is more like a personal opinion.
Okay. Thank you.
Okay, but Des, you wanted to say something? But before this comes to the mic, but the operators wants now for like 5 years already, or even more, the content providers to pay them to transport.
For the use of,
Yeah. So this is actually addressing the real situation.
The European Commission is trying to, propose certain solutions.
Please.
Yes. Desiree Milosevic, co-chair of the Cooperation Working Group, where we address these issues, and thank you, Elena, for bringing this interesting thing to the meeting. I'd like to say that that these interconnection charges are supposed to be covered in this peering arrangement, which is close to the sending party pay. So we have done the cooperation working group, which all you can subscribe to the mailing list, is a place at the right community that addresses these policy issues, and we interact with the public sector, so we invite the speakers. And we would like to also have another intersessional on this topic sometime in the near future, if we don't cover it in Krakow. But we have had a working group. It was a small task team that looked through the questionnaire of the consultation on the future of public infrastructure. And so our conclusion was also something that Jelena mentioned of the small task team, that there is no reason to change the current setup.
And if we have time, there are questions I'm happy to take, but I just wanted to mention another argument that has been circling around. This is the arguments of the telecom operators. They say we need to think about the sustainability and the environmental impact that these large content operators have. Because if the internet usage and our networks are being used more and more, and we need to increase the capacity, we also need to think what kind of impact, as I said, is going to have on the environment. And maybe we want to introduce some kind of environmental tax that is going to be charged to the content operators.
That's the never-ending discussion.
Yeah.
Okay. If there are no other comments or questions, thank you, Elena.
Thank you.
Who's next?
So we have next Roman Lapac from Poznan Supercomputing and Networking Center, PSNC, with presentations about the case of GP4L.
Yes, thank you. Yeah, my name is Roman Lapac from Poznań Supercomputing and Networking Center, and together with Professor Sonia Filipowska from the University of Skopje in North Macedonia, we prepared a set of slides to prepare the work on orchestration and automation solutions in the Jean project and deployment in the GP4L infrastructure. So I will say a few words about the Jean network. So today morning, Maria Isabel already did it. Just let me say a few words, that's enough. Then I will say more about GP4L and the automation orchestration solutions in that infrastructure. Okay, Jean. So as you already know from Maria Isabella presentation, it's a pan-European network infrastructure to interconnect NRNs, National Research and Educational Networks. It's for students, for researchers to share data, to exchange data, to run experiments, to test new ideas, new technologies, etc. So I personally represent PSNC. We are Polish NRN. We operate our national network. We connect Polish universities and Polish research institutions, and we have direct connection to the Jean infrastructure. But it's not only the European level, it's also the global level. So NRNs have collaborations with research institutions from other continents via Jean infrastructure, but not only infrastructure, because we have a number of initiatives, collaborations with our partners. A nice example is the Personal system, the monitoring system. Probably, maybe some of you know what it is. So it's being maintained and developed by people from the Jean project, from US, from Internet 2, University of Indiana. There are guys from Brazil, from RNP. Okay, global platform for labs, GP4L. So GP4L is divided into two parts. The first one is the infrastructure, programmable based on the P4 switches. The second part is the playground for pilots, for tests of automation orchestration solutions. So let's start with the infrastructure. It's a programmable network P4 infrastructure of P4 switches to run experiments of the newest technologies, ideas, etc. So this information that you see on the slide is wrong. Yesterday I noticed the mistake because it's not for the Jean community only. It's for all researchers interested to run experiments, P4-based experiments. And there is a core of this infrastructure composed of 9 P4 switches owned by Jean project. But there are much more nodes, P4 nodes from our partners. We call them community. So their nodes are located in US, in Asia, in South America, also of course in Europe. So right now we have more than 40 nodes in GP4L infrastructure. So it's possible to run a nice, really nice global experiments there. Okay, second part of GP4L initiative in the Jean project. This is a playground to run tests, to pilot solutions using the infrastructure. Yeah? We have a few work areas interesting for us. So for example, digital twin, which is the a virtual copy of the network infrastructure. Next work area interesting for us is orchestrated automated network service provisioning with orchestrators, automation tools like Ansible, single source of truth, scheduling, monitoring, and network configuration backup applications. We're interested in network visualization. Yesterday there was a presentation about NetLab, and the D2 language was mentioned for the visualization. We also use it. It's very useful. Next, network management in the cloud. We have in the project the software to set up a system which offers the virtual isolated environment. This can be used to create a kind of virtual NOC. Next work area for us is education. We have internal collaboration in the Jean project with eAcademy team. They share the learning units, and we also work on them. Okay, the components, the building blocks that we use to develop automation orchestration solutions in GP4L. So let's start with orchestrators, because right now we use 2 implementations of them. It's usually a key element of our implementations. Right now we use Camunda implementation, but also Apache Airflow. There is also another one quite robust called Workflow Orchestrator from Surf. Another building block that we use in our implementations is automation tool. We usually use Ansible. Another thing is source of truth that keeps information about the state of network, the desired and true state of network. And also virtual twin that we used for pre-production tests to verify configuration changes before deployment in the production infrastructure. So these are a kind of building blocks. So let me say a few words more about some of them. Source of truth. I don't know if you know this, but probably yes. It's quite known right now. So this component stores desired state of network. Yeah. So if the configuration of devices are different, it means different than what we have in single source of truth. It means the configuration is wrong and should be updated, should be corrected to be consistent with the state that is stored in the single source of truth. And single source of truth is the essential, is the key element of the infrastructure, the code system to automate service provisioning instead of doing service management in a manual way. So in the project we use two implementations of single source of truth. One is MAT and second is Netbox, also quite well known tool. But let me say a few words about the MAT because it's something new developed in the Jean project. So this is the application to store information about the logical and physical resources and instances of services. Some characteristics of this application is that it exposes open standard-based APIs. The team that developed this tool didn't reinvent the wheel. They took specification, API specifications from TM Forum. Yes, and the API can be authenticated if needed for the deployment. Important thing for source of truth is a flexible data model. We also took it from TM Forum. It's extensible if we need some extensions to describe services, to describe resources, for example, some attributes, more characteristics are needed. It's doable, it's simple, very flexible. The application can support more than one data models. There is an even notification mechanism is implemented so that external application can listen to the notification, can receive notifications from MAT about any changes in MAT, for example. If a new service or resource is added to the application, then listeners, the external application can be notified about it. And technology behind the application, there's a NoSQL database, MongoDB, it's Java application, there are Docker files for the deployment, and if authentication is needed for API, Keycloak can be used. This application, as I said, is the new one, fresh. We have a new website for it. If you are interested in the concept of source of truth, if you are interested to get to know the features, installation, configuration stuff, then you can find all those information under this address. I mentioned earlier digital twin for automation is a key element as well, just like source of truth. We are going to use it for pre-production tests, so to be sure that the configuration changes are verified before the deployment in the production infrastructure. To produce this digital twin, we use Container Lab. It was mentioned yesterday also during the presentation about NetLab. it's quite nice, quite useful tool with the long list of supported virtual routers and network operation systems. And what we like is the integration with Netbox, because there is a software called NRX from NetReplica that helps to export network topology from Netbox, and this is a file, and this file can be uploaded to Container Lab, and in this way the infrastructure stored in single source of truth in Netbox can be recreated quickly in Container Lab. For example, for some pre-production tests. Okay, use cases in GP4L. So we managed the GP4L infrastructure manually. So we decided to automate those operations. We identified two main use cases, resource management and resource reservation. Resource management is when a GP4L partner wants to connect a new GP4 switch to our infrastructure. So you can see in the central place the orchestrator. In this case is Camunda. There is a single source of truth, Netbox, that where user provides information about the new node. So this action executes a workflow, implemented workflow in the orchestrator, and the information are forwarded to Uptime Kuma, which is the monitoring, simple monitoring application. And also the information is automatically forwarded to Oxidize. This is the tool to back up network configuration. So if the admin will change something in the Netbox, it will be reflected, the information will be forwarded to all the tools as well. Second use case, for reservation, as I said, GP4L can be used for infrastructure, can be used to run experiments. Those experiments needs to be reserved. The nodes, the resources must be reserved beforehand. So we, in this use case, we have Libra booking application for reservation. We replaced Camunda orchestrator with Apache Airflow. Again, we have a Netbox as a source of truth, and we have the application to manage access. It's called Bastion, to manage access to the GP4L switches. Yeah, so when the reservation should start, then the workflow is executed in the orchestrator, and all the information, needed information, goes to Bastion to open access to the resources, to selected resources earlier by the user who created the reservation. One screenshot I put on the slide on the left side. Yes, on the left side you see the Netbox, on the right side Uptime Kuma. So in Netbox you can see few devices with some interfaces, active interfaces. So if interfaces are active, then the monitoring is running for them in Uptime Kuma. When a user change the status of interfaces or remove devices from source of truth, automatically this information is propagated to Uptime Kuma, to monitoring, and the relevant interfaces are no longer monitored. I want to say a few words about the NMAS platform I mentioned in one of the previous slides. It's a system it's a software, but it's also a service that we have in Jean to set up a virtual environment to create a kind of virtual NOC with management application. It's based on Kubernetes cluster with management, network management application catalog, so a user can choose which application is needed. All use cases that we implemented run in this environment, this platform. If someone is interested to run it, to install it, and private resources, it's fine. The sources, the code is available, but we also in the project have production service, so one can contact the team that maintain this service, request an account, and play with this system. One can check how it works in real life. Okay, service provisioning pilot. Right now we are implementing this system for Pioneer Polish network. So the goal is to automate all the services that we have in Pioneer. We identified all the workflows. We started implementing them. We described our resources and services using the data model that we took from TM Forum. It's a quasi-standard, I think we can call it. Yes, and we already know that there is an interest to reuse this implementation in other NRNs. For example, Renator and French NRN, they also are in the beginning of the automation journey in their network. So they are waiting for the implementation, and later they will test if it fits for them. Okay, future work, we will continue the work on this pilot for Pioneer network. There is also a discussion about services for GP4L infrastructure. Our work is the research work, so all the time we test technologies, some implementation solutions that might be helpful on the work on orchestration, automation stuff. And as I said, we have a close collaboration with e-Academy initiative in the Jean project. So we are involved in creating learning units to share our experience, knowledge. Yeah. So here on the last slide, you can see the link on YouTube. You can find there a demo of implemented use cases. It's around 20 something minutes. You can see how it works in the real life. If you have any questions, if you're interested in the P4 GP4L infrastructure to run some experiments, or if you know some people who are interested to run such experiments, we are open. There is a email address to contact with us. Yeah, that's all. Maybe my private one last comment that I know that today I've heard that next RIPE meeting is in Poland, in Krakow. So I encourage you to go there because it's really beautiful city. So
thank you.
Thank you.
Any questions? No? 3, 2, 1. Thank you very much.
Thank you.
So next we have Nikos Kostopoulos from National Technical University of Athens. Privacy, aware zone exchanges.
Sorry, how do I find my presentation?
It will show up in a moment.
Thank you. Hi everyone, I'm Nikos. I'm from National Technical University of Athens, and I will present you part of my work for my PhD, which was completed 2 months ago. And the main idea of this presentation is to enable privacy-aware zone exchanges. Sorry, maybe I'm... What? Sorry.
This one.
Ah, okay.
Green forward, red backwards.
Thank you. And in this presentation, I'll present a privacy-aware schema that relies on hash names stored within probabilistic data structures. The main idea of probabilistic data structures compared to deterministic ones is that they do not store information in its actual form, but first the information is hashed, so it is stored in an alternate form that in order to be so that the data structure is more time and space efficient, and also it introduces some privacy-aware properties. However, this is introduced at the cost of having some errors when using the data structure. And we're mainly based on these data structures in order to enable the efficient DNS zone distribution to external security appliances, for example, recursive DNS services or scrapping service providers where something, a security measure can take place. For example, DNS stack mitigation closer to attack sources or filtering of malicious names generated by bots across a local area network. And we enforce some design requirements for our mechanism. The first one is it should be privacy aware and it should map names in time and space efficient format. It should support existing DNS request types, for example, AXFR and IXFR requests, in order to get full copies of the zone as well as updates of that. And of course, another problem with probabilistic data structures is that we do not always have dynamic incremental updates. In order to fulfill these design requirements, we selected a data structure that's called cuckoo filter that supports element deletions. Some very brief maths about the cuckoo filters. In cuckoo filters, elements are inserted as fingerprints in the entries of a two-dimensional array. Of course, the fingerprints are hashed, so this is where how DNS names are somehow protected, they gain privacy properties. And cuckoo filters are characterized by 3 parameters: the number of the available buckets, M, the number of fingerprints, fingerprint entries, B, that could be stored in each bucket. For example, you can have a bucket that accommodates up to 4 fingerprints or 8 or etc. And the size of the fingerprint, which is the main thing that affects the accuracy of the mapping of DNS zones. And we have some math there that describe how the elements are hashed and accommodated to the specific buckets of the cuckoo filter. In this figure, we present the 4 entities of our mechanism. Of course, we have something that's called Privacy-Aware Zone Manager, which is mainly a Python program that coordinates zone management and maps DNS names into zones that are based on the contents of cuckoo filters. And we have 3 kinds of zones. The plaintext DNS zones that contain the names in their actual form. This is unhashed. The hashed DNS zones, which include the names, all the names of the DNS zones hashed and mapped into the fingerprints of a cuckoo filter, and the incremental DNS zones, which are retrieved using IXFR, and they include recent zone updates. Here, we focus more on the hashed DNS zones. If you want to learn more about incremental zones or other parameters of the mechanism, you can refer to, I can point you to the paper that we published. And let's focus now on hashed DNS zones. These zones hold the full qualified domains of the plaintext DNS zones, hashed and mapped in cuckoo filters. And you can see there that we have a serialization format. You can see that the parameters of the filter, as well as the algorithms, are mapped in the resource records of the DNS zones, as TXT records. But the main idea is to focus on the cuckoo filter data and how the names of DNS zones are mapped as fingerprints of the cuckoo filter. You can see here an example of the first DNS resource record of a zone corresponding to our NTUA.gr zone, of our university zone. You can see there that we map up to 85 DNS names. You can see that there are some rules over there. Of course, names are mapped as hexadecimal digits in order to gain some to earn some more space. If you have let's say a smaller fingerprint, you can see there that we accommodate 3 bytes per fingerprint. If you have a smaller one, you can prepare it with zeros, and all of them are sequentially mapped up to the maximum limit of the TXT resource record, which is 255 bytes. Of course, I know that in the RFC, you can TXT records can map more names, but this complicates much the implementation of our mechanism. And now, as an experiment, we are evaluating the privacy of the cuckoo filter. And in order to do that, we are going to look up all the possible name combinations. We will create all the names that could be included in the DNS zone and check the true positives and the false positives. The true positives are the positive lookups for names that are already stored in the cuckoo filter. These are the correct answers of the filter. And false positives are the erroneous answers of the filter. It is, yes, this name belongs to the filter, but in reality, it is not stored there. And what we want false positives to be significantly more than true positives, which means that the discovery of the real names that are stored inside the zone is next to impossible, and the hashed contents of our cuckoo filters are protected with high certainty. And you can see here that we took all the permitted name combinations for the first label of our NTUA names from 3 to 7 characters. And the permitted characters are letters, digits, and hyphens. We stored in the cuckoo filter approximately 8,300 names. And you can see there in the table that for small names, for example, 3 or 4 characters, you can see that the true positives are very similar to false positives. This means that someone could take a look, an attacker could find some information about the zone, but as the prefix length grows, for example, for 7 characters, you can see that the false positives are much more than the true positives, around approximately 70,000 times more. And this means that our hash names are protected with high certainty. Of course, if you test it with longer prefixes, for example, 10, 15 characters, the false positives will increase significantly. Thank you.
Thank you very much, Nikos. Are there any questions, comments? No? 3, 2, 1. Thank you very much. Thank you.
Thank you. You notice that we are already in the lightning talk sessions. I forgot to mention. So next lightning talk is from Tassos Meletlidis from Hack the Box, with the presentations, brief guide on protecting BGP from bad actors. Tassos? Is here? Okay, so Tassos, the floor is yours. The other one.
Sorry, yeah. Okay. To begin, my name is Tassos Meletlidis. I work as a challenge creator at Hack the Box. And today I'll show you a brief introduction on BGP hijacking and how to protect from bad actors that exploit BGP hijacking. So, what is BGP hijacking? Basically, it's the unauthorized takeover of a BGP route. It can happen both intentionally and unintentionally. So, best case scenario, you have a network outage. Worst case scenario, you have a big-scale DDoS attacks and man-in-the-middle attacks. The reason this happens is because BGP by itself doesn't have any security measures implemented. And even though there are a lot of security measures developed, not all network operators choose to use those. So, IP hijacking. So, in BGP hijacking, we have IP/prefix hijacking. Can happen in 3 different ways. You can either have an AS that announces a prefix that it does not actually have the right to announce. Then we have another scenario when you have 2 ASs. One would be the normal AS and one would be a malicious one, so a compromised router. And in that case, the compromised router could announce a more specific IP prefix, and because BGP usually prefers that one, the traffic would be directed to that one. And on the third case, we have an AS that we have, again, 2 ASs, but in that case, they both announce the same prefix on the same subnet, but the malicious one can include in the AS path messages a more specific path, and because BGP prefers that one, then again, you would have BGP hijacking and the traffic would be directed to that AS. Here I have an image of a very simple BGP hijacking man-in-the-middle attack. So we have AS100 that's announcing the /23 subnet, and we also have the malicious AS140 that's announcing the /24 prefix. In that case, because /24 subnet is more specific, all traffic that would that's supposed to be going to AS100 would go through AS140. And that could be done also in a way that it would make no difference to the end user, because AS140 can then direct the traffic back to 100, and this can cause a lot of bad things to happen. There are also other types of BGP attacks. We have the TCP/IP protocol attacks. That happens because BGP is built on top of TCP/IP, so all common attacks that affect TCP/IP could also affect BGP if not enough security measures are implemented. We have the route manipulation attacks, which include the BGP hijacking, which I just talked about. We have protocol manipulation attacks. These attacks are a bit more rare and new, and these happen when basically you are trying to influence the behavior of the BGP protocol. And also we have denial of service attacks by resource exhaustion. In this case, we would have a BGP speaker that's either being flooded by a lot of BGP messages or messages that are improperly formatted, and this, depending on the BGP software, this could cause a DOS attack. I have here some real-world examples. I'm not going to go through all of them because I don't have time, but I will say a common thing that I've noticed is the other day I was looking at a chart that's showing the increasing amount of BGP hijacks that happen the last years. And the common thing you would notice is that a lot of these affect specifically cryptocurrency and decentralized types of sites. So I find it a bit funny because all these sites are promoting decentralization and whatnot.
Talk to the mic, please.
I was not talking to the mic the whole time? Okay, I'm sorry. So yeah, I've noticed that a lot of these attacks specifically target cryptocurrency sites that are supposed to be decentralized, but because they all rely on a single point of failure, that is their website that's not decentralized, they are being attacked all the time into this manner. Methodology of protecting BGP. So 4 main things that are to look out for is BGP speaker authentication. So validating if the speaker that you're talking to is allowed to talk to you. Origin validation. So if the AS that's announcing a prefix has the right to announce that prefix. A path validation. That's when you are checking the AS path. You are checking if the message you received has actually taken the path of the path attribute that it includes. And then we have BGP update message. My bad. We have attribute verification that's done on BGP update messages. And there you're checking if the other attributes are correct, properly formatted, and you are ready to accept them. For protecting the BGP session, there are a lot of techniques that are implemented. Here are the most common ones. We have TCP MD5, which comes pre-installed in most BGP software. basically uses a MD5 signature to validate if the BGP messages are spoofed or not. Then we have TCP/AO, which is supposed to be an improvement of, it's supposed to improve of the weaknesses of TCP MD5. It's not as widely used, but it's gaining more adoption, so that's a good thing. And then we have GTSM, which is, uses another way of validating if the BGP messages are spoofed or not. We're using the TTL attribute. Route filtering, so that's something that you should definitely do when trying to protect BGP. It can be done both on inbound and outbound traffic. There are two main approaches of doing that. You either allow all packets to pass and then you filter out which ones you want to deny, or you deny all of them and then filter out which ones you want to permit. Two main rules of doing the route filtering: you should filter as close to the edge as possible and as precisely as possible. Prefix lists are also something you should definitely use when doing route filtering. I have here three tools that are mainly used for connecting to RIPE or other RIRs for getting Route 6 objects. And these objects, depending on the AS you provide, tell you the prefixes that that AS is allowed to announce. Other important prefix filters are special purpose prefixes, unallocated prefixes, longest accepted prefixes, and routes that contain their own prefixes, so you should filter out your own prefix on your router, IXP LAN prefixes, and the default route prefix. Last but not least, we have RPKI, which is a great innovation. It uses certificates that can be delegated from RIRs to LIRs to do route origin authorization, my bad. And really RPKI is great. I think all network operators should adapt and try and use it if they're not already. And basically that was it. I hope it was a good crash course on BGP security. And I also want to mention that on Hack the Box we have a challenge that includes BGP security. So if you'd like to see more of a practical approach to that, feel free to check it out. And also big kudos to the RIPE Academy team for the BGP security course. It's a really great course. It's for free. It has easy to understand information about BGP security. So that was it from me.
Thank you. Any questions, comments? Nope. We're tired, huh? Okay. We have another lightning talk.
Yes, we have a RACI submission, which is the last lightning talk from Hueja Zubair Sediki from Max Planck Institute for Informatics about analyzing long-lived MOAS prefixes in BGP.
Has been a long day for all of us, right? Probably some of us are tired. And it's me standing between closing plenary and finishing this SE meeting. So I will try to keep it short. I know we are all tired. We had a lot to learn. I'm Zubair, a final year PhD student, and I'll present one of our research work, co-authored together with my professor Anja Feldman and Oliver Gesser. It's about prefixes or IP prefixes that originates from more than one autonomous system, which is somehow correlated to the previous talk, hijacks. But I will look at a different perspective in this study. So that's why we use the term long-lived, the prefixes that appear for a longer period of time, as with multiple or more than one origin is. Typically, what happens is, if you look at this graph, usually AS1 might announce a prefix, but there could be a malicious intent or a hijack, shown in red, that could announce the same prefix and could cause you a hijack, a disturbance in your traffic, or it could reroute your entire traffic. And these incidents happen in the internet. this is actually a MOAS prefix, because one prefix is originated by more than one autonomous system. Now, it's also possible that more than one AS announced one prefix, but it's not a hijack. So we were wondering what could be the possible reasons. However, technically, both of them, they look exactly the same in the routing table because they both have more than one origin AS. The first question that was a bit difficult for us to answer was how to distinguish between the benign case and a possible leak or attack. So we used time frame, and we said, if a prefix is announced for a longer period of time, we find 30 days as a proper bar between the hijacks and the non-hijacked ones. So if they appear to consecutive days for 30 days, at least they stay in the internet as a MOAS, then we call it a long-lived MOAS prefix, and we try to study them further. But why this topic is at all important? I mean, nowadays we are talking about IP geolocation. So if you're ending with AS1, then the geolocation is country A, and if you map that IP to AS2, then the geolocation address is actually another country. So that it is important. Or we also talked about Anycast services. We wonder how much of these MOAS prefixes could be used for Anycast, and generally we wanted to know who are the users and how these MOAS prefixes are used in the internet. Because it's a great approach for creating resilience for your network or doing some load balancing. If one path to one of your AS is down, then the secondary will still take the traffic. What we did was we took daily RIP snapshots from route collectors from January 2017 till January 2023. And we check how many prefixes appear as a MOAS, and you can see that sometime for a short-living period, these MOAS prefix makes up to 10% and even 15% of the entire prefixes in the global routing table. Some incidents we notice which could be a hijack or unintentional, or I think it's mostly unintentional, but I cannot prove it. Angolot cables on that period, they generated nearly 90K prefixes, and later on Huge Networks, which is a DDoS mitigation company, they also announced around 143K prefixes as MOAS prefixes. But we are interested in the bottom part, which are the prefixes that they left more than 30 days, 30 consecutive days. So these prefixes had a growth from 1 to 2%, if you look at the blue line for IPv4, and they exist in the internet. The first thing was to do a basic checkup. So we did an RPKI, or a row state check for the MOAS prefixes to see if the prefixes that we talk, if they are actually valid. And as you can see, the orange line shows the MOAS prefixes that they have all the origins valid in the row state. So this assures us that we are using data that is used by network operators. And the green line shows that if at least one of the origin was valid, so we call it partial valid. And less than 1%, we notice that they are all invalid, like we do not find any valid status for them. And the blue line is for the not known or unknown state of the MOAS prefix. Next, we took a look at the CIDR sizes. What are the common CIDR sizes in the internet? And it's very similar to the general CIDR size pattern that we see in the global routing table. So the /24 is the dominant one, and 48 is the dominant for IPv6. The left plot is for IPv4, the right is for IPv6, and the y-axis shows the fraction or the share in thousands. But there are some spikes in the data, and we were curious to see what's happening in that period. So the first one for IPv4, it's the merger of the two telecom companies, or probably the acquisition, TTNet and Turk Telecommunication. The merger, they cause a lot of MOAS to generate, and later on Jastel acquired by Orange. I think the deal was earlier, but technically you see it in the routing table later on, and also acquisition of KPN by GTT is causing MOVA's prefixes for IPv6 on that period. Next bit was, if you have more than one origin, how does your prefix origin pair propagate in the internet? For this one, we use the route collector peers. So on the x-axis, you see the number of peers. And we try to understand if a prefix with AS1 is visible across how many peers comparing to the same prefix with another origin. So as you can see the pattern, one line is very visible, like across many peers, route collector peers or feeds. And the second has a low visibility. What does it tell us is that probably MOVAs are not mostly used for Anycast, because then it would be that you get both origins with a good visibility or widely propagation in the internet. We used the BGP tools data to cross-check it with the Anycast, and we noticed that nearly 1% of IPv4 and around 6% of MOVA's prefixes, they are actually Anycast, but remaining of them, they are not listed, at least limited to that data set, they're not Anycast. And interestingly, we find out that A and J root DNS servers, they're also hosted on MOVAs. However, on their website is not listed, like their prefix is not listed as a MOVAs. And they're both hosted on VeriSign infrastructure. To conclude, in this study we did 6 years of analysis of RIPs to identify MOVA's prefixes. We extracted MOVA's prefixes that live longer, and we see that they are the result of merger and acquisition. Mostly when we check the relationship between the origin AS of MOVA's prefixes, they are customer provider. So the customer announced the prefix and it also requests a provider. And also they are rarely used for Anycast. What we suggest is probably it's better to remove unnecessary MOVA's prefix, creating or increasing the routing table size. Thank you for your attention.
Thank you very much. Any questions? Of course.
Hi,
Rolina.
Franziska Lichtblau, SAP. Question, you started out that you were not sure with this multi-origin AS prefixes whether are you looking at hijacks or are you looking at something that's actually genuine? After looking at this data and coming up with your metrics, how confident are you that you can give us some ideas, some suggestions? Can you come up with metrics for other people who look at that in terms of validity versus benign prefixes?
Mm-hmm. So there has been some studies. Most of these hijack incidents, they last, 80% at least in some of the studies, they say it's the network operator take action and they try to prevent it. And there might be still some small fraction of them. I think with the time frame that we are using and with the pattern, the rove state of the MOVA's prefix that we see with valid state, we are kind of pretty sure that the benign use cases, they are consistently announced for period. There could be some short announcement as well to fix some network operational activities. We are not neglecting that part. But generally, we think we are sure, and we think it's actually the lower bound of the information. So there might be many more MOVA's prefixes that's not visible actually in the route collectors, but it might be in the internet because our study is limited to what we get from route collector peers. But thank you.
Actually, I was quite surprised to see the number of /49s up to /128s going around the internet. That's amazing.
There was, if I'm not mistaken, are you referring to
here.
The blue line here?
Yeah.
Yes. We also did another study, particularly on this one, and I think it was RIPE 86. So this one, we checked it, I think for some time when they were migrating, or they were doing some operation between KPN and GTT, they used it, and there was also some reports I cannot verify that there were some submarine cable cut or something. So I thought there is some temporarily infrastructure connectivity going on. That's why they announced these small CIDR sizes, and then it creates MOVAs.
Because the shorter than 48 shouldn't go on the internet, it should be filtered. But anyway, it's fine.
Just hyperspecifics.io, because I collect daily all the prefixes from /49 to 128 that appear in the internet.
How well we do the filtering.
But that's a big argument or discussion.
And I don't see people rushing to the mics. Thank you very much.
Thank you.
Okay, there is no closing reception yet because Hisham has some closing remarks. This way, not the other way around. Okay, I would like to thank you, everybody, from the behalf of the SE Program Committee to be here. I hope you liked the program. Send us a message or talk to us if you liked the program that we chose, or if you didn't like it, so we can make it better next time. And thank you. Hish, the floor is yours.
Yep, thank you for that, Jan. Thank you all for coming for the SEE 12 meeting. This slide doesn't have my name, but I remember. My name is Hisham Ibrahim. I work for the RIPE-NCC. You've heard me on stage before a couple times today. I make a point of changing my outfit just to confuse you every time and for the photo's sake. But this is the last time you're going to see me on stage. So we wanted to say a few thank you notes to a few people that have helped make this event such a successful event as it was. And first, we need to thank our local host, Longcom. They did an amazing job. Please join me in helping them. We finally got, yes, George, please. They are the reason. Finally, we managed to come to Greece. They were great hosts. George, please come on stage. They had the lovely booth outside, the staff in the back. They were helping. This was amazing. So very much appreciate that, George. Thank you.
Thank you.
If you want to say a few words while I got this.
Thank you all again for coming. It was a great pleasure to see you and meet you, even old friends and new friends that we've made here. It will be a memorable thing that we will actually never forget. For me, as I said again, it was a dream that come true to host RIPE in Greece. So thank you again for everything.
Yeah, perfect. Thank you very much. Sorry. And yeah, this is for you as well. Thank you very much. Yeah, thank you for that. We also like to thank our sponsors. The RIPE-NCC is a diamond sponsor for this event, but we also have sponsors that help make this event successful as well. That is IPv4 Global, Helco, and sorry? Salamanders. Yeah, there you go. They both had booths outside, and we very much thank them for their support for the events. So if you know me, you know I like data, and they make a point of putting data on these slides at the end of every meeting. So just looking at the meeting in terms of numbers, we welcomed 195 participants from 26 countries. 99 participants were newcomers, and that's no surprise. This is the first time that we come to this meeting to Greece. So we're very happy to see a large participation number from Greece here, being the top one, 84 from Greece. We're seeing a lot of participation, double digits from Albania, Romania, Serbia, and even Italy. So this is really great. I like to see double digits from neighboring countries coming into a regional meeting, because that's what makes a regional meeting successful. So really, thank you all for attending. attending, and this was really a great event. I appreciate that. I also like to thank the RIPE NCC staff that I believe did an amazing job. If you are in the room, please stand up so that people know and can give you that respect that you have deserved, I believe, during this meeting. Yes. They put a lot of work and effort into preparing this event months in advance, and if things went without any issues, it's because of the hard work and diligence that they put. So that is really appreciated from the RIPE NCC staff. The program committee, what can I say? Without the program committee, we wouldn't have a program, we wouldn't have a meeting. So really, program committee people, please also stand up and get the recognition that you deserve. And if you can join me on stage, we have a small token of appreciation for you, so please. If you guys can queue here for a nice photo. Yeah, on stage, up here. Yeah, up here. Yeah, we'll take a photo first and then I'll distribute the thing. So, guys, photo. Okay, yeah. I can probably stand here. In the middle, please. You can tell I don't do this stuff often, right? Yeah, much appreciated. There is money. There is? Yes. We really much value your feedback and comments here. So we have a QR code. I'm going to leave that up for a minute. Please put up your phone. Just get the URL for this. It goes through a quick survey that allows you to assess the event and let us know what you think. I mentioned in one of the talks that we use NPS, Net Promoter Score. So this helps us know how much you valued the meeting. And if there's stuff that we can do to make it better, we always want to hear that from you. So keeping it up there, I'm happy to see a lot of phones up. The more feedback that we get, the better we are in organizing these things. And yes, for those of you that have not heard yet, the plan is next year that we will be going to Sofia for SEE13 in Bulgaria. More details will be on the website soon. We tend to not announce the location until we have a contract, just to be sure. So that will happen very shortly, and I really hope to see you all there. And we are looking for a host for SEE14. So if you are interested in hosting this event in your country in April 2026, please let us know. We will be very interested in doing this. With visiting Greece this time, the SEE meeting has visited all of the Balkan countries and the extended SEE countries, so we're very happy with that. So we're circling back, and we are interested in visiting your countries with this event as well. And yeah, before I go into this, I also want to recognize somebody specifically here. She's standing in the corner over there. Kajal, she's the one that organized the event. She's the one that made a lot of this happen. there's a lot of people that go into the success of this event, but usually the events team are the ones that are, in the front and making sure that all these elements come together. And this is the first event that she's organized for the RIPE NCC by herself, supported by Sandra, so that was very much appreciated. Thank you, Vasja. And Sandra's in the back there, I see her as well. Sandy. Yes. RIPE 88, you've heard, Poland, we'd love to see you all there. And if you cannot be there in person, maybe host a remote hub, a local hub in your country and allow more people to come and participate locally. Please do. And yes, we do have, so thank you for coming. We do have ways for you to keep in touch. There is the mailing list for the SEE region. Please feel free to subscribe to that. We also have a RIPE NCC forum. And there is a reception that will be held on the 9th floor here. But before I finish, I also want to thank everybody that's in the room that has spent the past 2 days with us at this event. Please give yourself a round of applause. There's been a lot of topics, a lot of presentations. It's been a lot, it's been intense, but it's been amazing. And I really love this event. It's one of my favorite ones. And I thank you all for making that such a success. And with that, I believe I officially close the meeting. So thank you. See you at the reception.